Okay, so welcome to the SAIME, the web conference today that we are going to have today here. And as you know, that SAIME stands for the Sustainable Aquaculture in Mangrove Ecosystems. And we are into a project which is titled Multi-Stakeholder Partnership to Strengthen Transformative Processes in Shrimp Trade as a basis for the protection of the mangrove ecosystems. And we are very fortunate that with the financial support from the German corporation BMZ and Global Nature Fund Germany, along with strategic partnership with Naturland Germany, and the implementing partnership with Bangladesh Environment and Development Society BEDS in Bangladesh and Nature, Environment and Wildlife Society News in India, we are organizing this web conference. And the context is that the mangrove ecosystems of South Asia needs protection, and shrimp aquaculture has always been associated with some forms of degradation, some destruction of the system, and every ecological practitioners are raising their brows, whereas the aquaculture practitioners are trying to vouch for the shrimp trades in very many various means and ways. And what we are trying to do as practitioners and as part of the SAIME is trying to understand, because the context, because shrimps and mangroves are very, very intricately connected. And so are the farmers, the fish farmers and the shrimp. They are also connected very, very intricately, and there are predominant occupational activities related to shrimp in the coastal regions of both India and Bangladesh, and also other South Asian countries. Now, as I said, that the shrimp aquaculture is often associated with destruction of the ecosystems and many things, but some words keep on spinning around us related to this, like the sustainability in the aquaculture, like the farmer's role in the value chain, ecological restoration, production, because the blue carbon is now a huge thing and a lot of investments are coming here. Government of India is also looking in a very big way here. And the standards for certification, what should be there, the trade, the invasiveness of certain species, the local indigenous species, the traditional knowledge, and lot of these words keep spinning around us and really spinning our head. So we are very, very fortunate today that we have with us the various experts and practitioners who have been in this field for quite a long time, with their energy, with their experiences, with their knowledge, technical expertise, and grassroots embeddedness of their presence with the farmers, in the consumer markets, in the trade fairs, in the certification levels, setting standards. So all these, we are very fortunate that all these are very important to address these problems, and we have representative speakers, experts from all these areas today. And I would like to welcome you all, our distinguished speakers, Professor Sarder Islam, who is the professor and head of the agrotechnology discipline in the Khulna University of Bangladesh. Then we also have Mr. Moritz Konz, who is the project manager in the Global Nature Fund Germany, and young aquaculture specialist who is working with heart and emotions into this field. Dr. Debashis Dey is a very veteran scientist, the principal scientist in the Central Institute of Brackish Water Aquaculture, SIBA, Indian Council of Agriculture in India, one of the leading premier institutions in the brackish water aquaculture. And then we also have with us Dr. Profullo Kumar Sarkar, who is the former Deputy Director of the Department of Fisheries, Bangladesh, and has a long experienced career and expertise, commitments, contribution in the fishery sector in the Bangladesh. And we also have with us Dr. Stefan Holler, who is an expert in sustainable aquaculture, working with Naturland, Germany now. And you can find his name in the Google if you can type a little bit on sustainability in aquaculture. So we are very glad to have with you all. And I am Ajanta Dey. I am the Joint Secretary of Nature, Environment and Wildlife Society. We also have with us Mr. Milan Sinha, who is the fishery expert working with us. And we have with us, I know, our friends from BEDS, our colleagues from News, our friends from Germany, and other parts of South Asia who have registered here today. And I wish that this interaction would bring you positive thoughts and some really concrete thoughts on which may not be a very culminating one, but thoughts with which we can go forward and try to understand the various complications and complexities in the systems that we are working, especially in the aquaculture region, shrimp trade in the tropical mangrove ecosystems of South Asia that connects to the trade of the Europe and other states of the countries of the world. And so I would not waste much of the time because we want to really listen to the speakers. And here I would first address Professor Sarder Islam. But before that, I would like to just remind all my distinguished speakers that we have 30 minutes of time, but try to finish your presentation, your deliberations within 20 to 25 minutes so that we can have interactions and the participants can put their questions to you directly once they have got you in their hold now. So they can put their questions. And I would request also the participants be free and post your questions in the chat box. We will definitely look into it and try to address as much possible within the framework of this web conference. So welcome all of you again, and let me give the floor now to Professor Sarder Islam to give the keynote address. As I already introduced earlier, he is the professor and head of agrotechnology discipline in Khulna University in Bangladesh. Sir, the floor is yours now to speak. Thank you. Sir, if you can unmute yourself.
Good afternoon. Can you see my screen?
Okay. Yes, sir, we can see your screen.
Just a moment. Okay. Welcome our SAIME members from Germany, India, and Bangladesh, and distinguished participants. Welcome to my keynote presentation. The title of today's presentation is Propagation of Culture of Penaeus Vannamei in Sundarbans, its potential and challenges. And myself, Professor Sarder Islam. I'm from Khulna University of Bangladesh. Just have a look of the contents of my presentation. I'll go for introduction, taxonomic classification, biology and life cycles of Vannamei, growth rate, stalking density, disease resistance and salinity of Penaeus Vannamei. Why we will go for Penaeus Vannamei culture, advantages and disadvantages of Penaeus Vannamei, risk and threats, biodiversity and impact on wild stock, potentiality and challenges of introducing Vannamei culture in the Sundarbans region. And finally, I will conclude. First of all, the introduction. We know that the Penaeus Vannamei, which is also known as Pacific white or white-leg shrimp, and the home tract of this Penaeus Vannamei is the Pacific coast of Mexico and Peru. These shrimps usually grow in tropical marine areas where the temperature usually higher than 20 degrees Celsius throughout the year. It can tolerate a wide range of salinity, which is ranging from 0 to 50 ppt. The adult Penaeus Vannamei live and lay its egg in the ocean ecosystem, where the PL migrates towards the coast and spend throughout their growing period in brackish water or less saline water in inshore lagoons or any other mangrove areas. We know that the marine brackish water production is increasing day by day, and it was around 10,000 metric ton in 1970, but now the production is 4 million metric ton in 2014. However, it is crossed 5 million metric ton at this moment. The total shrimp production worldwide, the Penaeus vannamei is the major species which accounts 80% of whole shrimp production of the world. And we know that the annual economic losses account for 1 million US dollar per year since 1990. Virus and bacteria are the main causal agents for diseases of shrimp. Here is the taxonomic classification of Penaeus vannamei. We know that the Penaeus vannamei belongs to the kingdom Animalia and phylum Arthropoda, subphylum Crustacea, and it also belongs to the family and superfamily Penaeidae, and the species is Penaeus vannamei. And there is a synonym of Penaeus vannamei, which is Litopenaeus vannamei. It is also called white shrimp, white leg shrimp in English. This name Penaeus vannamei was derived by L. Booney in 1931, and his article was published in the Bulletin of American Museum of Natural History in 1931. Now the biology of Penaeus vannamei. Penaeus vannamei is mainly found on mud bottoms. It is grayish white in color, and the maximum weight of female Penaeus vannamei was reported 120 gram in nature, but it is the maximum, not the average weight. While the males are lighter than females, and the highest weight of male was reported 60 to 80 gram in nature. It prefers clay loam soils. The optimum range of temperature for species is 30 to 34 degrees Celsius, but the growth rate of Penaeus vannamei virtually stunted at or below the temperature of 20 degrees Celsius. However, it can tolerate a wide range of salinity from 0 to 50 ppt, but the uniform ppt for the normal growth is 10 to 40 ppt. They can grow in fresh water also, but the growth rate is slower as normal. Suitable pH range from 7 to 9, while the optimum pH is 8 for their normal growth and development. Dissolved oxygen requirement is more than 4.5 ppm. Considering the feeding habit of Penaeus vannamei, it is omnivore. That means it can eat both plants and animal sources, and it's a good scavenger. And it is less aggressive and less carnivore as compared to our black tiger shrimp, which make it to culture at a very high stocking density. It is a nocturnal feeder. It means it prefers to eat in evening and night. And retention of food in their digestive tract is 2.2 to 5 hours. The shrimps attain its average production weight is 20 gram within 100 to 120 days. However, it depends on the management, feed, and stocking density. Life cycle of Penaeus vannamei. They usually, the life cycle of Penaeus vannamei is as a typical shrimp, belongs to the family Penaeidae. The adult live in the sea until reproductively mature, and they usually lay their eggs in the marine environment. And an adult shrimp can lay 100,000 to 250,000 eggs at a time. They lay eggs in the sea, but the larvae try to migrate towards the inshore. And first larva, PL usually try to migrate toward inshore, and they pass their entire growth period in brackish water or less saline water. This is the main reasons that make it possible to culture them in inland in brackish water pond, because it can also tolerate low salinity. Here is the escase. This is not mine. I need to acknowledge the Rosenberry who developed this escase. According to the escase, it is visible to see that the adult lives in the deep sea and lay its eggs into the sea, and their larva gradually develops and try to migrate towards the inshore, and their post larva usually pass their entire growing period in estuary and less saline water, brackish water, and towards their maturity, they again return to the deep sea where they complete their total life cycle. Growth rate of Penaeus vannamei. It usually grows faster than our black tiger shrimp, but it is up to 20 gram. After 20 gram, their growth rate become very slow, and it is at a very high stocking density of 150 per square meter. Their growth rate is up to 3 gram per week. Although it will keep growing beyond 20 gram, but the growth rate is become very slow, that is 1 gram per week. Under commercial condition in Asian earthen ponds, their growth rate is 1 to 1.5 gram per week in Thailand and Indonesia. But in contrast, the growth rate of our black tiger shrimp is less than Penaeus vannamei, that is 1.2 to 1 gram, and the survivability is less, that is 55% to 54%, the survivability. But the survivability of our Penaeus vannamei is 80 to 90%. Stocking density. It is possible to culture Penaeus vannamei at a very high stocking density, that is 150 per square meter. However, at a very controlled condition, it is possible to culture 400 Penaeus vannamei per square meter, which is not possible in case of our black tiger shrimp, because Penaeus monodon is aggressive and carnivore, and it needs better environment and better feed to culture them in an intensive condition. Salinity tolerance of Penaeus vannamei. I mentioned earlier that it can tolerate a wide range of salinity, which is from 0 to 50 ppt. However, the optimum salinity is 10 to 15 ppt to ensure their normal growth and development. This tolerance of Penaeus vannamei in a wide range of salinity is make them possible to culture them in inland, is in brackish water also in Latin America and also in Asia. Temperature tolerance. It can also tolerate a low temperature of 15 degree even, but the growth rate is slower, below 20 degree Celsius. Dietary protein requirement is also important characteristics of Penaeus vannamei is that the dietary protein requirement is 20 to 35%. Considering the uh, protein requirement of black tiger shrimp is 36 to 44%, and their feed conversion ratio is also very good. That is 1.2 compared to our Penaeus vannamei, that is 1.6. It means that they can convert feed efficiently than Penaeus monodon into their muscle. It means that they can attain 1 gram of live weight taking 1.2 gram of feed only. Disease resistance, Penaeus vannamei is less susceptible to white spot syndrome virus as compared to our black tiger shrimp. Therefore, the survivability of Penaeus vannamei is higher than monodon. Breeding and domestication. Availability of one reared brood stock. That means the brood stock is available in the rearing pond also. Sorry for interruption. Sorry. It's good. The Penaeus vannamei is brood stock is able to produce in the rearing pond also. This is for this the elimination of problems associated with wild brood stock and PL collection is not necessary from the nature. A specific pathogen free and a specific pathogen resistant lines also available, and source of safe brood stock from the ponds. Larval rearing, the survivability of larva is higher as compared to your Penaeus monodon, that is 50 to 60%, where the survivability of larva of Penaeus monodon is 20 to 30%. Why we will go for Penaeus vannamei culture? Due to high market demand, with a desire to expand, intensify, and/or diversify aquaculture system. The main reason behind the importation of Penaeus vannamei to Asia has been the poor performance, slow growth rate, and disease susceptibility of black tiger shrimp. Disease outbreak caused by viral pathogen resulted significant losses to the shrimp culture industries, that is black tiger, in Asian countries. After the introduction of Penaeus vannamei in Asia, the production level began to increase. Advantages of Penaeus vannamei: it grows faster than Penaeus monodon, up to 20 gram. But after attaining 20 gram, the growth rate becomes stunted. It is possible to culture them at high stocking density, that is 150 square meter per square meter, due to their less aggressiveness and also their less carnivoreness. It is tolerant to wide range of salinity, I already mentioned, and it can tolerate low temperature also, and it requires low protein diet. It is easy to breed species. That means the breeding is not so difficult, and commercially available, specific pathogen free and specific pathogen resistant, and high health stock added more advantages of rearing this Penaeus vannamei. Selective breeding work for production of a specific pathogen resistant brood stock is easier because of their short generation period, short life cycle. Higher survival rates in hatchery also has a very good market as most preferred species with higher meat yield, that is 66 to 68%. Disadvantages of Penaeus vannamei: it is highly susceptible to some viral diseases like taurine syndrome virus, white spot syndrome virus, yellow head virus, and lymphoid organ vacuolization virus also. Due to culture of Penaeus vannamei under high stocking densities under intensive management, it might lead to environmental problems like nutrient loading into the pond. Penaeus vannamei is highly susceptible to hypotoxicity. That means it needs continuous supply of oxygen or air into the pond. Handling, processing, and transporting of Penaeus vannamei are more difficult as compared to Penaeus monodon. And there is a high competition in the international market due to worldwide production of vannamei. Risk and threats. It is evident that viruses that were previously confined to Latin America, such as Taura syndrome virus, are taking a toll within Penaeus vannamei shrimp aquaculture in many countries in Asia. This TSV virus was initially identified in Penaeus vannamei near the Taura River in Ecuador in 1992, which causes severe production and economic losses in shrimp sectors. Similarly, white spot syndrome virus, which was initially identified in Penaeus monodon in China and Taiwan, was contaminated to the Penaeus vannamei in Latin America also. But the Penaeus vannamei is less susceptible to white spot syndrome virus. Risk and threats. The overall performance of Penaeus vannamei as a candidate species within the shrimp aquaculture sector in Asia is still not clear. An understanding of the social, economic, and environmental impacts resulting from the introduction of these species into Asia is still lacking. A newly introduced species, it is uncertain how vannamei will behave and perform in this region and what impact it will have on the regional economy, environmental sustainability, rural livelihoods, and also biodiversity. Biodiversity and impacts on wild stocks. Although Taurine syndrome virus does not yet seem to have affected the indigenous cultured and wild shrimp population, time and research effort have been insufficient to prove this. PSB is also a highly mutable virus capable of mutating into more virulent strains that are able to infect other species. And other virus probably imported with Penaeus vannamei, for example, a new lymphoid organ vacuolization like virus have been implicated, which causes the slow growth rate of Penaeus monodon in Asia. There remain many unanswered questions regarding the possible effect of introducing these species on other cultured and wild shrimp population in Asia. Potentiality of introducing Penaeus vannamei culture in the Sundarbans region. Penaeus vannamei has been introduced and farmed in Asia since the mid-90s decade, with production being particularly significant. Availability of a specific pathogen-free and a specific pathogen-resistant stocks make them possible to introduce it into the Sundarbans areas. Less susceptible to white spot syndrome virus than Penaeus monodon. A shortage of Penaeus vannamei in the international market. Due to the effect of climate change, the salinity level of Sundarban coastal regions are increasing, which may be a future threat for black tiger shrimp culture in this region, because black tiger shrimps are not able to tolerate high salinity level, like vannamei. Penaeus vannamei has short life cycle and ability to produce the brood stock within the culture pond. This removes the necessity of returning to the wild for brood stock or PL collection from the nature. Other specific advantages are rapid growth rate of Penaeus vannamei, tolerance of high stocking density, tolerance of low salinity and temperature, lower protein requirements, and therefore the production cost is also lower, certain disease resistance, high survival during larval rearing, and some marketing advantages. Challenges of introducing Penaeus vannamei culture in the Sundarbans region. A lack of knowledge of culture technique, particularly the brood stock management in this region. Lower mature weight and hence lower prices than Penaeus monodon. the need for high technology for intensive pond management, high competition with Latin America for markets, a lack of support for farmers due to their often illegal status. The major disadvantages of using exotic aquatic species such as Penaeus vannamei is the potential to transfer serious pathogen, for example, the virus. Finally, the conclusions. Due to its high stocking density, high salinity tolerance, lower production cost, and short life cycle, there is a great scope of introducing this exotic Penaeus vannamei in the Sundarban's coastal regions. Less disease susceptibility of this shrimp species can ensure lower risk to the farmers. However, due to high stocking density and intensification of Penaeus vannamei farms, the possible negative impact on ecosystems should keep in mind during introduction of this species. And thank you very much for patience hearing. This is all about my presentation. The floor is open for question and answering.
Thank you so much, sir. So we have known the geography and history of the species. We like the shrimp so much on the plate, but it's really interesting to know the journey, the so much of the culture specifications and the challenges, and it was really an enlightening one. And we have sir two questions for you. That one is that the salinity requirement of the Vannamei, because we know that, as you have said, that the salinity is changing and there are a lot of issues related to that, and that monodon cannot withstand so much of salinity. So one question goes into the salinity requirement of Vannamei, and there is another question that says that is it possible to spread the stop the diseases at any stage? Are there scope? So these are the two questions we have received from participants. Thank you, sir.
Okay, thank you very much. As I mentioned earlier, that the Penaeus vannamei can tolerate a wide range of salinity, that is from 0 to 50 ppt. But however, the optimum ppt for their normal growth and development is 10 to 40. And these wide range of salinity tolerance make them possible to culture them in our brackish water also. As I mentioned that the mature vannamei live and lay their eggs in shrimp in the ocean ecosystem, but they are also able to grow better in less salinity and also high salinity. This make them possible to culture them in a wide diversity of ecosystem. This is the answer of first question. And another question is the disease resistance. As I mentioned that the Penaeus vannamei is less resistant to white spot syndrome virus, which is more devastating for Penaeus monodon, which causes serious damage of Penaeus monodon culture in Asian countries. But this vannamei is less susceptible to this disease. And the specific pathogen-free and a specific pathogen-resistant brood stock and larva PL are also available in the market. And this, if we start with this kind of pathogen-free or pathogen-resistant larva, it is possible to control the diseases throughout their rearing period. But we have to ensure that the parent stock or larva is from a specific pathogen-free or a specific pathogen-resistant stock. Those are available in the market. And it is very easy to produce because of their less or because of their short generation interval, short life cycle. It is possible to produce and grow this specific pathogen-free and pathogen-resistant stock, so that it is possible to control and prevent all kinds of diseases in during vannamei production.
Thank you, sir, very much. If we have any more questions, I don't see anything in the chat box or in the question answer column. Uh, if other panelists would like to add anything, or shall we shall shift to the next speaker. Sir, would you like to, Professor Sarder, would you like to add anything else, or we conclude
Uh,
this?
uh, I have nothing to say. If anybody asks me any question, then I can answer it. Otherwise, I tried to explain their life cycle and their biology and their everything in my presentation.
Okay. Yes, sir. Thank you very, very much. And we look forward if some more questions come to you. I will put it into you at the end of the session so that
Okay.
all the questions the participants have are answered from the experts. And now the keynote address, after this keynote address, we would now like to hand over our floor to Mr. Moritz Konz, who is the project manager of the Global Nature Fund in Germany, and he will be presenting on the comparative analysis of the culture between the Penaeus monodon and the Penaeus vannamei. Over to Moritz.
Thank you very much, Ajanta, and also thank you very much, Professor Sarder, for giving the introduction. 1 second, I try to share my screen. Please let me see. Let me hear when you can see the
Yes, we can
presentation.
see it. We can see it,
Perfect.
Moritz.
Great, thank you very much. So as Ajanta already addressed, I'm going to speak a little bit about a comparison between Penaeus monodon and Penaeus vannamei in regards of their culture and the species. I'm very happy that Professor Sarder introduced the species that well and also gave some information about the comparison as well. So I might keep it shorter at some points. My vision of my presentation today is to just visualize differences and just give a hint about it. I don't want to go too much in detail because Professor Sarder already gave us a lot of information about the biology, which is very good. So I'm going to speak about the species itself, the production form in India and Bangladesh, how it's varying, and also about the culture risks of the production forms. And what I would like to address as well is information about the origin of the species and how this is shifting regarding to the culture. And as well, I would like just to give a little hint about alternative species. So, as Professor Sarder already explained, this discussion is about Penaeus vannamei, or better said, the white-lead shrimp. I'm going to compare it to the more traditional Asian shrimp species, that is the black tiger shrimp. Yeah, about the biology, black tiger shrimps generally tend to get much bigger than vannamei shrimp. And this is also a case which shows result in the marketing of the shrimp, because often consumers tend to have larger or small shrimps. So this is a big impact as well. And you can see clearly that the black tiger shrimp has this predominant black markings, and the white leg shrimp are more clear in color. So I don't go further on the biology of them. So what is very interesting is the distribution of these two species. So originally, Penaeus monodon is from Asia. It was distributed from the coast of Australia, Southeast Asia, to even Eastern Asia. But if you compare it to the map I added below, you can see that the distribution for the aquaculture has a much further range. So the aquaculture of Penaeus monodon is widespread over the whole Asian world, you can say. And I will go in detail about the production numbers later. And compared to Penaeus vannamei has originally a totally different distribution. Vannamei is originated from the coast of Mexico down to Peru in the East Pacific. And the distribution of aquaculture is very interesting in comparison to that, because Penaeus vannamei is cultured mainly in the US and also in South America, as well in Asia. So there has been a huge traveling for the Penaeus vannamei because they are very much widespread all over the world, and one of the most, or are the most cultured shrimp species up to date. So I would like to talk about the production volumes in India and Bangladesh, just to give a hint how much it's changing lately. I was searching for this information at Seafood Tip, the seafood sourcing intelligent portal, and they have really up-to-date numbers. And I already also compared them to the numbers of the FAO fish statistics tool, and, or better said, seafood statistics tool. And I was able to find out that during the last years, the production in India of Penaeus or little Penaeus vannamei has increased drastically, and the amount of produced Penaeus monodon is reducing quite a lot. Alone in India, there have been up to 600,000 tons of production of Penaeus vannamei alone in 2017. And yes, yes, and there's no. I'm sorry, I'm confused. There were a total production of 600,000 tons of shrimps generally in India, and almost 90% of this was Penaeus vannamei. So monodon is getting cultured less and less in India. The current situation in Bangladesh is quite different, because up to date, there is no culture of Penaeus vannamei or the white-leg shrimp allowed by law. So I know that there are some testings going on, as far as Professor Sarder informed me, but currently the main production is Penaeus monodon. And also Macrobrachium rosenbergii has a big impact in Bangladesh and the production. Generally speaking, there are approximately 60,000 tons of Penaeus monodon currently produced in Bangladesh. Regarding the culture systems, there's also a big difference between the two species. I would like to start with Penaeus monodon. Professor gave very detailed information, so I won't talk about salinity, etc. I would like to give some approximate numbers. We need to keep the numbers approximate, because it's always depending on culture system, stocking density, as well as temperature and environmental influences, and also whether feed is given or not. So it can just be taken as a general baseline, but mainly for Penaeus monodon, extensive culture is done. And this extensive culture is, for example, very typical in Bangladesh. I think far over 80% of the production is done extensively. And extensively means there will most likely be no feed additives, etc. It's just a low stocking density from 1 to 4 post larvae per square meter. The productivity is quite low compared to other production systems with up to 500 kilogram per hectare per year, but more often it's much lower. And usually it's 90 to 100 days, 120 days per crop. As well, for Penaeus monodon, an option is semi-intensive culture, which increases the stocking density of post larvae up to 15 post larvae per square meter, and the productivity can be up to 1 ton and even further, depending whether there are whether feed is given or not. And regarding the production period, better said, the time per crop is also 90 to 120 days. A very unique feature that is that we are trying as well to promote in our project is the polyculture. Polyculture is defined by culturing different species in the same system. For example, in our case, in the pond system, there are multiple, for example, fish species or other shrimp species suitable for polyculture together with Penaeus monodon. And also in polyculture, usually the stocking density is very low, sometimes lower than 1 post larvae per square meter. And the productivity is also quite low, up to 500 kilogram per hectare per year. But as additive, you have different species in the pond, which also can contribute to your harvest. Compared to our friend Penaeus vannamei, usually Penaeus vannamei is not cultured extensively. The main cultures are intensive and semi-intensive. So intensive culture can have very high stocking densities. I also found the numbers of 400 post larvae per square meter, but that's very much unusual. But it's possible, definitely. Often there's a stocking density used from 90 to 180 post larvae. It is depending on the culture system and the area, of course. And the productivity is really high, can be up to 15 tons per hectare per year, and even more, depending on the stocking density, of course, and also on the water treatment, because even though Penaeus vannamei is tolerating wide ranges in salinity and also wide ranges in water parameters, there still need to be some measures taken to not lose the whole batch. Another not so intensive part is the semi-intensive culture with stocking densities up to 69 post larvae, let's say 70 post larvae, but it can be much lower. And the productivity, of course, is lower as well, up to 10 tons per hectare per year. Depending on feed additives, etc., the amount per days per crop can be shorter for Penaeus vannamei than for monodon. But as the professor already stressed, the growth of vannamei is very fast in the beginning, but usually at a bigger state, the growth rate is going slower, similar to Penaeus monodon. What I would like to address as well with this little graph is that there's also another potential that we are trying to figure out in our project. It is about the integrated mangrove aquaculture. And therefore, Penaeus monodon is very much suitable. As you might know, and Ajanta already explained a little, IMA farming follows a very simple principle of introducing mangroves ecosystems to our aquaculture farm ponds. And there's this system is also very much suitable for the farming of Penaeus monodon. And this is an idea of our project that we are currently realizing with our first pilot farms. As I mentioned before, there are multiple culture risks, I called it, depending on Penaeus monodon and Penaeus vannamei. I just made up the most obvious ones and wanted to just notify you regarding these issues. So as I'm showing in this little picture, there's a huge overlap in some of the risks. For example, one risk is salinization of the areas where the shrimps are cultured, because in the past a lot of rice paddies, etc., have been converted to shrimp ponds, and these ponds, it is very difficult, or better said, impossible to reconvert them to farmland. And so salinization through intensive shrimp farming can be a huge issue. The same is with the loss of mangrove ecosystems due to the widespread of shrimp aquaculture. In regarding for Penaeus monodon, there is also a disadvantage currently if the usage of wild post larvae is quite high, which it can be, or it tends to be in the areas, especially in the Sundarban. We need to consider that the catching of wild larvae does have a huge number of bycatch, which can lead to ecological problems. That is something we should not forget. Additionally, the intensive use in regard the intensive culture of Penaeus vannamei can have a lot of environmental impacts as well. For example, intensive culture requires a lot of feeding, and which results in a high nutrient load. And also intensive culture can lead, don't have to lead, but can lead to intensive use of antibiotics, for example, which is of course tricky for the environment. As Professor Sarder has already mentioned, the spread of exotic diseases like Torah syndrome and virus is also an issue that can be related to Penaeus vannamei, depending on the source. What is known by science that due to the widespread of Penaeus vannamei, exotic diseases have entered Asia that before were only found in South America. So there has been some transfer. And what is little known right now, and what could be a concerning point, is that the impact on wild stocks isn't that well known yet. Another thing that might impact wild stocks are escapees. Due to storms, tropical storms, or poor farm management, it can happen that some of the shrimps might escape and might enter the ecosystem that they not belong to. So there are some studies about wild caught Penaeus vannamei in Asia, but they are most likely related to escapees and not to reproduction yet. But I will go on this in detail on this topic later during my next presentation. So just to mention the risk of escapes, it is quite high with Penaeus vannamei. For Penaeus monodon, if it cultured in India and Bangladesh, escapees do not cause a big ecological harm, since the species is more likely native there. So what I would just like to mention are alternative species. There are many of them, like pink shrimp and white shrimp, that can be introduced to ponds due to natural inflow of water during the culture. Another alternative species is also Macrobrachium rosenbergii, It's a freshwater shrimp, which is also heavily cultured in India and Bangladesh. And it's also suitable for extensive polyculture. It has often a much lower stocking density and doesn't bring that much kilogram per hectare per year, like up to 500, but can also be considered as an option. But it has to be said that these shrimps are usually not that attractive for the European market if it comes to export. And yes, so just to mention, there are also other options, and polyculture is always an interesting way to go if we're considering different culture systems. So thank you very much for the attention. I made it really short because I didn't want to repeat too much, so we can go on very productively. And please let me know if you have any questions. Thank you for the attention.
Okay, thank you, Morris. I think it was a very, very interesting presentation with a lot of diagrams to understand all of us really the risks that are involved on the terms of ecological perspective. And I have a interesting question for you from the participants that among this Penaeus, monodon, Rosenbergi, and the Vannamei, which system is good for the mono and the polyculture? I think you have addressed a little bit, but if you can elaborate on it more.
I can elaborate on it more. I share my presentation again. Let me see. I'm just made these little tiny graphs. So maybe we can just have them here for us to visualize what is best. So what is best is a difficult question because we need to consider what we are what we want to achieve and what kind of ecological footprint we want to have. So this is something we need to consider. It is hard to give an advice which would be the best culture. So from my perspective, of course, extensive culture does have a minimal impact on environments if done responsibly and if done in a correct manner. Intensive culture usually, not always, can have higher impacts on the environment, depending whether there is some water treatment involved or whether there is depending on the farm management, to be honest. Farm management is one of the key factors in talking about sustainability and talking about suitability of certain cultures towards environment. I think this is also very much treated in different certification schemes. For example, even intensive culture can be certified, for example, sustainability, if there is a clear if there is a clear water treatment and the system doesn't, for example, pollute natural water sources. Another point that is very important to protect the ecosystems in regards to culture is also minimizing of escapes from farms. And that is something that always needs to be considered. Regarding polyculture, polyculture doesn't only mean that there are different species of shrimp together. There are also other fish species considerable for this culture. Some were experimenting with milkfish, for example, etc. And so there are many options for culturing. To say which culture form is best or is most suitable is, as I mentioned before, very hard and depending to many factors.
Yes, of course. The choice of the culture will depend on many things, which are to determine the nature of the culture methodology. But I think that the polyculture is always preferred being in the aquaculture. I don't know, but it's up to the experts decide. And I would like the participants to pose more questions to them, to the panelists, now that you have it within your reach. But as an ecological practitioner, I would always like that we have a polyculture mode, so that there is always a balance of everything and not mono domination of certain species. So this lovely pictures of this IMA farming is what we are looking at under the SAIME, and I'm very happy that Moritz has raised this beautiful picture, and we are all trying in India and Bangladesh to have farmers adopt this culture methods with the Penaeus monodon, the black tiger, which is the indigenous species in our area, and we all love to eat that. We all know that. So if we now go to our next speaker. So thank you first, Moritz. It was an excellent insight into the various areas that you wanted to highlight on the culture perspective. And I'm so happy that my panelists are always in time, and there is no like putting the bells. That's an awful task for the moderators. So thank you very much for that also. And now I would like to invite Dr. Debashis Dey, the principal scientist from the Central Institute of Brackish Water Aquaculture, SIBA, in India, to have his presentation on scope and challenges of Vannamei culture in Indian Sundarban. So, sir, to you to have your, the floor is now given to you, sir, to have your presentation and deliberations. Thank you, sir.
Thank you, madam. So, just I'm sharing my screen, just a minute. Is it visible, ma'am?
Yes, sir. It's visible.
Okay. So, good afternoon, everybody. So, myself, Dr. Dey, as just introduced by Ajanta Dey. Just I am a principal scientist and officer in charge of a center, regional center, which is situated at just in Sundarban, Kagdi. And it is our center is one of the oldest center, just belong to Central Institute of Brackish Water Aquaculture under Indian Council of Agricultural Research. So I'll be talking about today regarding the scope and challenges Penaeus Vannamei culture in Indian Sundarban. So my talk will be just covering all these aspects like Indian scenario in Bengal, this basic information about the Vannamei advantages already covered by these earlier two speakers. Then how this Vannamei has been introduced in India. Then what is the key to the success of the Vannamei culture, major challenges, guideline for mitigating the challenges, burning issues, and issues for slow propagations of Vannamei culture in Indian Sundarban. So I will come to this introduction, like this in India, this aquaculture is the fastest growing food producing sector with an average growth rate of 10%. And India is the second largest fish producing country with a total production of 13.75 million metric tons, of which this cultured fish is around 7 million metric ton. And Indian brackish water aquaculture is actually the economic engine of our Indian aquaculture sector, and which contributes less but 8 lakhs tons of the production, but it is an economic engine due to its value of its product. And India is having the large resources of the coastal lines, around 1.2 million hectares, and It is also having some inland soil affected area, huge area, 8 million hectare covering the Rajasthan, Haryana, Punjab. This side 8 million hectare of this inland soil affected area. So it is having the huge potential. And if you see the major commodity of this brackish water aquaculture sector is the shrimp, which is contributing around 6.9 lakh tons and earning about 47,000 crores Indian rupees. 47,000, more than 47,000, and it is contributing around 5.23% share of the agricultural GDP of India. So, and if you see about the Indian Sundarban, it is the largest mangrove ecosystems, and it is covering area of 9,630 square kilometer. And here brackish water area, potential brackish water area is around 30 to 50,000 hectares, and only 20%, 20 to 30% area is under aquaculture at present. If you see the brackish water aquaculture development in India, you can see that our West Bengal, that's where this our Indian Sundarban part is there. That West Bengal is the leading state having the highest coastal area, actually around 4 lakh hectares. But the area developed is much higher in the Andhra Pradesh, and our area only we could develop only around 15% of the area we could develop for the brackish water aquaculture. And if you see the present Indian scenario, this Vannamei is the major and the main export item, and which is earning around 25,000 crores of Indian rupees in 2018-19. And this in area under this Vannamei culture, this is around 93,500 hectare area, and in West Bengal it is around 4,000 hectare. And production in the later this 2017-18 data says this production increased around 6,22,000 tons, and which is 24% more than the previous years. And it is contributing, this Penaeus Vannamei is contributing 90% of the total shrimp production. If you see the graph here in India, it started in 2019, and it started with 1,700 tons. So today it has come to 2017, 6,22,000 tons. Whereas this monodon, there's a black tiger shrimp, it was earlier around the 100,000 tons. So now it is coming around 60,000 tons. And if you see the West Bengal scenario, where our Indian Sundarban is there. There we started in 2012, after 2012. There, if you see, we started the Vannamei production here around 500 tons, and now it is around 22,000 tons. So, and but in West Bengal, if you see the monodon is also increasing. Earlier it was around 49,000 to now it is around 50,000 tons of this productions in the West Bengal itself. So, and if you see the potential in the Indian scenario, this West Bengal scenario for the brackish water aquaculture, we are having the brackish water available area 210,000 hectares, of which around 60,000 hectares is under use. And here mostly traditional polyfarming, that is in agriculture is practiced mostly. And this area mostly, if you see the three districts in West Bengal, North 24 Parganas, South 24 Parganas, and East Midnapur. These are the major. This is the main district which is having the brackish water aquaculture practices, of which North 24 Pargana is having the major area around 35,000 hectares, and then followed by South 24 Pargana and then East Midnapur. But if you see the scientific shrimp farming, here the scientific shrimp farming major area is covered by the East Midnapur. And South 24 Pargana and North 24 Pargana, it is around a total around 800, only 800 hectare is under scientific shrimp farming. So if you see the potential is huge, but now as at present only 8% area is in the Indian Sundarban, we are doing the scientific sim farming. So, and this Vannamei farming, as I told earlier, it started in West Bengal in 2012. And but you see, in the by 2017-18, it has from 500 tons to it has increased around 22,000 tons. And this previous year it was more, 26,000 tons. And most of the around 95% of the present area, these peoples are doing Vannamei culture. And the basic information already, this has been covered by my earlier speakers. This is a native species of the Mexico and South America, and this is a common name, white leg shrimp. It can tolerate 15 to 35 degrees centigrade. And this, though its optimum, this condition of the culture is around 30 to 34 degrees centigrade. It can tolerate even from the fresh water to up to this high salinity, around 50-50. But it grows uniformly in the 10 to 30 ppm salinity, and it is the most widely cultivated species in the world. And it is the advantage is because it can tolerate low temperature up to 15. It is the advantage over the monodon, and it utilizes the organic matter more efficiently. It grows faster, as already told by the speakers, and it can tolerate high density rearing. So the speakers are telling even in the controlled condition, it can go up to 400 PL per square meter area. So this kind of potential is there, this advantage is there of this Vannamei. But it's again, this protein requirement also is less, around 30 to 35%, where this monodon, it is around 36 to 42%, and then it can tolerate the poorer water quality. Yes, poorer water quality it can tolerate than the monodon, and its culture duration also short, because in 90 days when it is coming to 20 grams, you can harvest. So these farmers can take 2 to 3 crops per year, and as it is having the open thalicum, it is easier to breed. So, and this is specific pathogen free and specific pathogen register, and broodstock is readily available. It is the advantage. Then if you see the history of the Vannamei introduction in India, then in 90s, when that WSSB came and this total industry, modern industry has went off, and then farmers were looking for the alternative species. So how to go about? Then Government of India took initiative to introduce the Vannamei. And then 2003, they have given permission for the culture on a pilot scale. Then 2007, this risk analysis study has been done by our institute and along with the National Bureau of Fish and Resources, ICRs. And after they just given the report, then 2008 committee constitutes the committee for the making the guidelines for this culture. And 2009, Coastal Aquaculture Authority framed the guidelines and given the permission for introducing the Vannamei, for introducing culture of the Vannamei in India. Since then, this Vannamei culture is going on, and if you see the major factors for success of the Vannamei culture, if you see, if you just keep in mind these 5 points, then you can be successful for the Vannamei culture. So first is the pond preparation. Your pond, as I will come in the detail for the one by one. The pond preparation has to be proper, and there's you have to take the certified and tested seeds. Your stocking should be proper. You should not go for the high density for the sustainability kind of thing. Then you need to give the good quality feed, and your feed management should be very strict, and you have to be very closely watch the feed management practices. Then you have to maintain the biosecurity point, so that the disease should not come into your ponds, and then you have to maintain your optimum water quality to give the optimum environment to your animal. So this is the 5 key points for the successful Vannamei culture. So I'll be coming on the one by one. So first, pond preparation. If you just do the good pond preparation, it will reduce your risk of the disease, and it gives you the better protection. First, you have to just expose the pond bottom to sunlight until, like this picture shows, that until it cracks. Then you have to remove the black soils, then you have to just apply. If your soil is acidic, you have to give the lime as per the given dose. You have to adjust. If you want to give the dolomites, so those will be like this. So you have to test your soil, and accordingly you have to just apply lime to keep the soil pH around 7.5 to 8. And then you have to take the water or the just pumping from your creek. Then you have to take the water through 3 mesh system, 40, 60, 80 mesh filtration, and then you have to fill the pond. And then for the pond preparation, you need to give the at least after taking the water, you have to give the 15 days time for preparation of your water. After giving this 1-2 meter depth of the water, you just fill, then you left for the settlement, then you coordinate your water, then you put the organic juice just for the development of your primary productivity. Then you can put your soil and water probiotics. Then you have to give your dolomites to again help for the planktons to grow, and then again another dose of this organic juice. Then finally on the 15th day, when this your water is having the enough primary productivity so that the first PL can survive with your primary productivity, you can stop your PL which is of the age of around 12 to 14 PL. So this way to prepare your pond. So first is the that for this it will increase your survival of your PL. So then you have to give the aeration properly. In the Vannamei culture, you need your when this production, your productivity is going to more than 2,000 kg per hectare. You have per 400 each 400 kg. You have to put 1 HP aerator. So that is the requirement for the aeration, and you have to place your aerator in such a way that your pond, your water is getting the maximum circulation. So and then when this your water is ready, you have fixed your these things aerations, and then another important point is the selection of the seeds. And then selection, you have to select the seed from the reputed hatcheries which are producing the good quality seeds. So and you have to select the seeds of the uniform size from the same batches, and this should have the good active seeds. And then stocking, you should not stock the PL less than 12 days old. So and you have to stock your PL more than 12, and your density you have to see that your stocking density. If you see our coastal aquaculture authority guidelines is maximum 60. But also I will say that for the sustainable point of view, your stocking should not be more than 40. Then only you can just, it will be sustainable. Your ponds will, you can culture for the longer period. And then but to taste your seed, whether it is a good seed, so there is a, you can do the stress test by just circulating your water, and if it is a PL is concentrating in the middle, that means it is not a good quality seed. So that way you can select your seed, and you have to acclimate before stocking. You have to acclimatize your seed to your pond environment. Suppose you are bringing this from the hatchery where salinity is more, so you have to more than your this pond water, you have to acclimatize the your seed to the pond water system. And this for the every, when you are going to downwards adjustment, so per hour 3 ppt you can adjust when you are going downward. But if your pond salinity is more than your hatchery salinity, then for each 1 ppt acclimatization, you need to spend 1 hour. Slowly you have to acclimatize, so that your survival, your PL will not get much stress, and the survival will be good. And this is and you need to stock during late night or early morning, and then for the getting the better survival. Then another important point is that because the feed management, feed is the major cost incurred for your expenditure, this Vannamei culture or any culture. So here in the Vannamei culture, around 60% is going for the feed. So your feed management has to be very strict, and so very rational, and so that you can get the profit. And you are not putting much feed into the pond and polluting your pond water, polluting your pond water. So you have to be very strict in your feed arrangement. So you have to provide the high quality feed to your Vannamei. And then feed intake you should monitor through check tray. You have to minimum 6 numbers of check tray you should put per hectare of area. Then check tray based, mostly this farmers use the check tray based feeding system. They depend on the check tray, but always it is not true. Check tray can mislead your culture, your requirement of the feed. So that's why you have to be cross checked with the conventional your feed requirement conventional formula. So then only you should give your feed. You should not put this more feed to your animal, so that your animal will not eat the your feed, and ultimately the pond water will be this environment will be polluted. And then feed should be reduced up to 50% when there is a major melting. Then during heavy rain also you need to just avoid feeding, and feed pallet size should be proper, so that when they are just big, if you give the starter feed, they have to spend more time to catch that feed. So there should be the pallet size should be proper according to just your size of the shrimp. So always you should avoid the excess feeding. And this is the feeding schedule. Mostly it is a very common, and mostly just I will differ a little with the Mr. Sarder. Actually Penaeus Vannamei, unlike monodon is the purely nocturnal in feeding habit, but P. Vannamei they feed mostly in the daytime. So by 6 p.m. We need to finish their feeding, and mostly we'll be giving the daytime feeding. And this is the daily ration for the first 50 days. This kind of ration has to be given. After that, as per the biomass, we have to fix the feeding chart as per the biomass. We have to fix, and the check tray also we have to give as per the table, that how much feed we should put in the check tray to check that whether feed has been finished in the check in the tray. Then only we can know that they are really taking the feed in the pond. So this is the different formula for the calculating the rations and the quantity of the feed in the check tray. And then the most important factor in the feeding management is, as I was telling, so don't feed Vannamei the tiger shrimp. Because why I was telling that if you just feed your tiger shrimp, we generally a major portion of the feed we give in the evening to night time. But here we have to major portion of the share you have to give in the daytime. And then here this quality of the feed means protein percentage of the feed is less. Requirement of the protein is less than the tiger, and then feed should be freshly manufactured. And daily ration, as I was telling, daily ration should be calculated based on estimated biomass, not always on the basis of the check tray. And then we have to estimate the biomass through sampling. Always we have to estimate this weekly sampling we have to do, and on that basis we have to estimate the survival, and we have to estimate the biomass your pond is having. And then as per the biomass you have to provide the feed, you have to offer feed to your animal. Then water quality management, the water should be depth should be around 1.2 meter. And liming should be done at the regular interval. As you know, this calcium requirement is very high due to this rapid molting. That the growth rate is very fast, so liming is required. And optimum pH range here is 7.5 to 8.5. And diagonal fluctuations should not be more than 0.5. It should always be below 0.5 diagonal variations. And then appropriate feeding, obviously, because this water quality is always related with the feeding. If you overfeed or excessive feed you provide, then your water quality will go down. So these are the optimal some water quality parameter for this culture, and the dissolved oxygen should be around 4 to 7, and total ammonia nitrogen should be less than 3.7 ppm, and free ammonia, which is most important, it should be less than 0.1 ppm, also less than 0.25 ppm. So this kind of the water quality if you maintain, so then your survival of the crop will be really good. And then mineral application in the pea Vannamei, this mineral, this year requirement is a little higher than the monodon, and because they are both the rate is faster, their molting rate is also faster, so they need more mineral, and so that's why we need to modify the water. Two ways there. One is the water modification, another is the application through feed. So majorly farmers practice and easier to feed is the this water modification, and water modification we modify the water as per the salinity, because you have to maintain the CO proportion of the different mineral as per the seawater. Suppose as seawater of 35 ppt, this is having the content of the sodium, potassium, magnesium, calcium, and sulfate this much. So that if you are having the salinity of 5, so you have to multiply it by the 5 with these factors. So that way you have to maintain your your mineral content of your pond water. So that's why you have to apply this your salt very often, this mineral in a regular interval for this Vannamei culture. And Vannamei can be always cultured in the freshwater, as I told earlier. It also helps in the reducing the disease risk when you are doing the low salinity culture, and it also eliminates the chance of escaping this exotic species. And it is when you are doing the zero salinity, means you can choose, you have the option to choose the place of your pond. It should be, you will always prefer to just make a farm nearer to your market. So there is a chance when you are doing the low salinity culture, proximity to commercial market, and this will help in the efficient use of the water. And it also reduces the chance of the salinization, one major issues for the Vannamei culture when you are doing the natural with your brackish water. So if you do the low salinity culture, there will not be the issues of the salinizations. And but for that, when you are doing the low salinity culture, water modification is required. You have to supplement the mineral, a lot of minerals, to maintain at least your salinity should be, so that 4 ppt salinity should contain how much mineral, at least minimum that much mineral you have to maintain in your pond. Okay, so then for the low saline water, you have to always analyze your mineral analysis has to be done, and split doses of the mineral has to be applied twice in a week, and PL should be more than 15 days old, and this better we have to acclimatize first in the nursery in the low salinity, then only you need to stock. And better to stock after when you are doing the mineral application, 3 to 4 doses of mineral application you do, then only you stock in the low salinity culture. So these are the water modification. For the water modification, you need to just keep in mind that major issue is the sodium potassium ratios, because if your sodium potassium ratios is not proper, it leads to the osmotic stress. So, and then this optimum sodium potassium ratio you need to maintain is 28:1. And magnesium concentration also you need to maintain in around 140 milligram per liter, means 140 ppm. So these if you maintain, then you can do the your low saline culture of pea Vannamei. But what are the major challenges? These are all the culture scope, and now major challenges. So major, it is a more input intensive, as you all know, because it is density is higher. You need to put the aerator, you need to have the ETP system, all these things. It is a huge more input intensive culture, and it is another challenge is it is a carrier of various diseases, as my earlier speakers were telling. It is a carrier of lot of viruses which may affect this our native species, and then when we are doing this our Vannamei culture, we can do it can just tolerate the high density culture we are telling. When you are putting the high density culture, then it requires the more feed. That means you are putting lot of organic matter into your environment, and a lot of fecal matter is getting produced. So you are leading to the environmental problem. So hydrogen, all so much organic load is coming to your pond system. So it is creating the environmental problem. And then it is a, and this P. Vannamei is a really is a major challenge. It is a very much susceptible to hypoxic condition. That's why you need to put aeration facilities very 1 HP per each 400 kg, as I was telling. You have to put because your oxygen level should not go just below 4 ppm. And this is another measure regarding the market. More competition, because Vannamei culture is going on all South Asian countries, American countries, all are there. They are competing with us. So there is a more competition in the international market. So for the Vannamei, whereas for the your monodon, so we are having the actually major share in the Asian in the world market. So we are having the more competitions in the international market. The other challenges associated with this farming is your poor technical knowledge of the farmer. Here, this farmers are over dependent on the company's technicians, over dependent, and credit-based farming. So they all are depending on the vendors are providing credit, and ultimately at the end of the culture, they are just purchasing all the produce. So, and they are deciding the market value also. So that way, farmers are not getting that much price of their produce. And then health risk is then because of the exotic pathogens might affect the native strains. Then ecological risk, because it may escape into the natural environment, which may affect our biodiversity. And if there's a or in Sundarban area, if Vannamei started increasing, it may lead to damages of the mangrove also. So that may lead to this destruction of the mangrove. And then environmental risk, as I told, that it leads to the high nutrient load in the this environment. Then converse social risk is coming. That's the conversion of the when there's agriculture and the salinizations. When we are this agricultural land, a lot of people converting their agricultural land for the Vannamei culture, and they are bringing the saline water from the distant places, and they are doing the culture. As a result, this nearby land is getting salinization is affecting the neighbor's land. So there is a social dispute is coming. There is a social risk, and it also disturbs this our traditional or improved traditional farming. As Moritz was telling about the polyculture with the monodon, all this is getting disturbed due to this may get disturbed due to if this all started doing our Vannamei farming. Then market risk, I was telling that due to increased global supply, price may fall, and there is a risk. So farmers may not get the profit, and then we have to always compete with the established player. So these are the guidelines of mitigating the health risk. To avoid the health risk, we have to always use the tested certified healthy seeds. We have to follow the biosecurity measures. So that our ponds are not getting affected with the disease. And then we have to use the feed from the good quality feed from the reputed companies, meant for the Vannamei. And always we have to follow the better management practices in all stages of farming. So these are the diseases of the P. Vannamei. And so far the Torah syndrome and this NHP, necrotizing hepatopancreatitis, is not, and yellow head disease is also not reported in India so far. And this ecological risk, this guidelines for mitigation is we should not directly release the wastewater from any facility, like from the quarantine, then from the hatchery or the culture area. We should not release wastewater directly. There should be effluent treatment systems for all the 3 stages, and then effluent treatment should include the chlorination and the dechlorination to prevent the escape of any pathogen, as well as our this exotic species in the system. And then guidelines for the mitigating environmental risk. we have to reduce the organic load. So with the stocking density, we have to reduce. Maximum, though permission has been given for the 60, but really to make it sustainable, we have to reduce the number of stocking for this our Vannamei, to reduce our nutrient load or organic load in the system. And effluent treatment system is mandatory. You should have the 10% area of your farm for this effluent treatment systems. And then for this mitigating economic risks, you have to adopt the biosecurity in your farm. And then you need to have the time to time information regarding the rate of your this product, so that you should not be cheated with your this vendor who has given you the credit. You should not be cheated. Then low density, you can make the low density culture, and you can produce the bigger shrimp, which can fetch the higher price. That can be adopted for getting the more profit. And then you should adopt the common reservoir or ETP system in your this thing. You make a cooperative, and you should have the common reservoir and ETP, so that you can treat your water in a common system, and then you can release. So it will reduce the cost, and then adoption of the better management practice in all the stages. Then some diseases, another challenges is the emerging diseases. Emerging diseases are coming, which is causing the really heavy mortality and the production losses. These diseases emerging due to there's more the intensification of the culture, and this increased transboundary movement. We are bringing this food stock from the other countries, and then we are bringing along with that some virus along with them. And in case due to the intensification, we are increasing the stress of the aquatic environment. So as a result, that these emerging diseases are coming. Some of the emerging diseases like EMS, though it is not reported in India so far, it needs the good pond condition to avoid these things. Use of the soil probiotics and the stocking healthy seeds may just reduce this disease things. And this is a IMNB, this muscle necrosis that is caused by the virus, infectious necrosis virus. For that, to mitigate these things, you need to avoid the stress. So you have to reduce the stocking density, and you have to just keep your soil and water quality optimum. So that if you can make these things, then you can avoid this disease. Then another is the running mortality syndrome. People are telling it is not actual disease, just symptoms. So as your stocking density high, it will be slowly mortality will be there for the so many reasons may be there for the running mortality syndrome. And so you need to reduce the stress. For that, you need to lower the stocking density, and your feed management has to be strict. And then another is the EHP, non-emerging disease. It is due to the Mycosporidium one parasite, and it will cause the really slow growth of the shrimp. So you have to get the tested seed which is free from EHP, and you have to follow the appropriate pond preparation methods. And this is major two burning issues now at present for the Vannamei culture. One is the slow growth. Slow growth is the really so many farmers are calling us, sir, our shrimps are not growing. This may be due to different things. One is EHP. So to just avoid this factor, you have to have the certified and the tested, which is the free from the EHP. That type of seed you have to stock. And seed may be from the pond reared brooder. So now so many people are doing the pond reared breeding, that due to inbreeding, so there this larvae will not be of the good quality. So there will be slow growth. Another major issues are the there's now we are getting that white fecal disease. This white fecal disease again due to the this poor feed management. When you are putting the more feed into the system, it is the bottom is getting disturbed. The bottom lot of gas will be entrapped, and then ultimately your animal will not eat, and the symptoms will be the white fecal. So it may be due to the EHP, or maybe due to the some Vibrio. So, but major reasons in your bottom is getting affected. You are putting the more of organic load in the system. So that is also coming now to us. And we are another major these issues are the local environment degradation. Definitely, when we are doing the this high density culture, we are putting lot of organic load to the system, and when we are, if we don't release our sludge or water after treatment, it will affect the environment. So we have to be very careful while doing the this Vannamei culture. We have to be we release the sludge or water after treatment, definitely. And another issue is that when we are doing, we have to keep in mind we should not convert our agriculture land to the this for the Vannamei culture. Though it is a remunerative, it is giving the more profit, but we have to keep in mind we have to eat rice. We have to eat wheat. We cannot just convert all the land, this agricultural land, to the for the Vannamei culture. So we have to keep in mind, and we have to, as well as we have to see that others, your neighbor is not getting affected due to your culture. So that we have to keep in mind always. And now and this is my last slide. Is what are the issues for the why in Sundarban, as I was telling, only 7-8% area is only doing the stream culture, scientific stream culture. Why it is not getting propagated in Indian Sundarban? So as per my views, so there is a huge capital intensive farming. Polyculture around 12.5 to 17 lakhs per hectare. You need the capital for 1 hectare area for the culture. So it is a huge capital intensive farming, and here Sundarban marginal farmer cannot afford this except a few. So that may be the major reasons for the slow propagations. And then another is the that is also related with the your capital intensiveness due to lack of farm infrastructure. Because for the getting the license for Vannamei farming, you need to have the proper system for the ETP. You need to have the reservoir. You need to have the ETP, and then only you will get the license. So that is also lacking in the Sundarban or Indian Sundarban. And another is the lack of government schemes or subsidies for the propagation. If the government is having some schemes for or subsidies they give the propagating, so it may just take off, or Vannamei culture in Indian Sundarban can be this rate of adoption maybe this faster. And then difficulty in availability of the seed, quality seed and quality feed. Yes, in Indian Sundarban, in India, in our West Bengal, there is no hatchery. So we have to always depend on the all southern states. So we are bringing the seeds from that far area. So it is involving cost. So that is the one reason, and also the quality feed. Really, we are not getting the quality feed, and if we are getting the quality feed, its cost is really high. So what as our research institutes, SIPA also produce the quality feed, and SIPA has set off the feed mill in the throughout the country for producing the indigenous and cost-effective feed for the Vannamei culture. So to give that kind of feed mill, if we can establish our indigenous feed, cost-effective feed, then I think Sundarban farmers can get benefit, and this aids adoption or propagation may be the faster. And then, as I told, this it is a Sundarban. It's the locational disadvantages there. So here people are not getting the close proximity to the market. They have to go for the market to the Calcutta. So then they're not getting that market rate. And for each thing, for the getting seed, feed, and also when you are selling your product, always you need to incur the cost, more cost. So that is another disadvantage, reasons for the slow propagations. And then unavailability of the aqua clinics. Yes, when you are doing any culture, you need to monitor your water quality or health of your animal. So you need to have aqua clinics in your hub where your culture is going on. If it is available, then it is very easy for the farmer to monitor their water quality. But in Indian Sundarban, it is not there. In East Midnapur, some of the aqua clinics are there, so they are getting that facility. So it is required to put aqua clinics here. And overall, this risk-bearing ability of this marginal fauna of Sundarban is less, because their margin, as I told, the risk-bearing ability is less. So they cannot afford, if they one time they get lost, they cannot stand up for future culture. So that's all about this my presentation. Thank you for your kind attention. Thanks.
Thank you, sir, very, very much. I think it was really very holistic, and we traveled through the Vannamei culture process actually, and very rightly you have assessed all the areas, the production aspect, the risks, threats. I have a lot of questions for you, but we are out of time, and so I will just take one now, and after this session, sir, I would request you to answer to all the questions. Some have already been answered through your presentation, but some I think are critical, which needs to be answered from you. But we'll go on to the Bangladesh presentation. But before that, I would just take one question that you have said that the feed management is critical, and but how critical it is that for so that it how does it affect the aquatic biodiversity? And the linked question is that in case that you have highlighted so much of the wastewater management, then does it directly lead to any fertilization process, or that we have to go for any treatment before we get into the fertilization process, or we can use that wastewater sludge into fertilizers? So I think the two questions are a bit related. So, sir.
So yes, first question is regarding the feed management. Yes, we have to strict feed management means you have to provide your feed as the optimum quantity. How you will give the optimum quantity? You need to know how much biomass is there in your pond. If you cannot estimate, if you cannot assess correctly the biomass of your this animal, then your and you apply your feed based on your check tray. Suppose check tray is finished and you are giving the feed next dose and the higher quantity, then that your quantity, your feed may not be utilized, may not be eaten by your shrimp, and ultimately your pond water will get polluted. So that is the reason I was telling your pond, this biomass assessment is very much essential. You need to know how much biomass is there in your pond. That's why I am telling this is a strict feed management. And then another thing is that you are telling about the wastewater, right? Yeah, wastewater management. Yes, when we are putting the your water in the before releasing into the environment, you need to just treat your water first for the absorption of your nutrient load. We are producing seaweeds, bivalves, so that all the nutrient load, organic load, most of the organic loads will be absorbed and by the seaweeds and the bivalves, and then you can coordinate if any your pathogens are there which can affect the this environment, and which can be passed on to our native species in our environment. So for that you need to do the coordination also. So these two things we need to do before releasing your wastewater.
Okay. Thank you, sir, very much for this very, very in-depth understanding of the process of the culture, and the advantages and also the disadvantages, the risks that it brings. So we will have the questions, sir. Don't forget that we have still the questions. So we'll take it later on at the end of the session of today's. Once again, sir, thank you very much. And now we go to, we open the floor to our renowned scientist, Dr. Prafulla Kumar Sarkar from Bangladesh. He's the former Deputy Director of the Department of Fisheries in Bangladesh, and he is going to speak on the P. Vannamei culture in Bangladesh Sundarban, the scope and the present situation. Sir, the floor is now yours to deliver.
Hey, dear participants, I am Profulla Kumar Sarkar from Bangladesh. Welcome, everybody, here, respected participants from different countries and corners. Today's topic on Vannamei in the mangrove of Bangladesh, why and how, its scopes, its potentiality and challenges. Before going to the today's session, I would like to have a quick look on Bangladesh shrimp industry, its trends. Our exportable shrimps are monodon and freshwater. Everybody knows productions of the above are not increasing. Exports are not also reducing, not increasing. BT have the nature of the features of our Bangladesh shrimps is BT, mainly extensive farms are not increasing, semi-intensive are not also expanding, no high-yielding variety like P. Vannamei. We cannot cheaper Vannamei to our customers, international customers. Shrimp industry in Bangladesh are improving day by day. It begins with 1 million hectare USD in 1973. It reaches up to 638 million USD in 2015. Trends are reducing after that. Although the present growth rate seems to be slow, but almost sustainable. Production increases slowly during the last 40 years. It shows reducing now. Raw materials comes from the expensive and improve extensive. Being popular extensive, we did not intensify our monodon culture. Per hectare production increased from 150 kg to 350 kg for BT, and that is 250 kg to 550 kg for Macrobrachium rosenbergii. Our farmed black tiger is about 78% of the total is almost natural, organic, without any chemicals, even without any commercial feeds. Quality of our shrimp products in Bangladesh, nobody allowed export without certificate, pre-shipment inspection and testing done before export, certificate issued with satisfactory results of health issues. For safety and quality, we have some rules. Deviation from any compliances have a provision of punishment. We have a very few non-compliances since the 2011. Our culture environment are still good enough. Facts of the above are based on NRCP conducted by CA. Existing culture pattern of the Bangladesh mangrove zone. Sundarban mangrove is a unique ecosystem suitable for habitat for shrimp aquaculture. But farming are not allowed within the existing forest area. Only flat plains can be used for shrimp farming. Actually, shrimp farming are coping mechanism of the coastal shrimp farmers. A suitable part of the coastal floodplain we can use for Vannamei. There are a lot of conversions on shrimp farmers are destroyed the coastal environment. But I would say coastal lands and water are gold mine. Shrimps and other crops are grown fine. Actually, it's a coping mechanism of our coastal farmers. When the water are saline, then they produce some shrimps. When the water are sweet, then they produce some rice or other crops. So it's a coastal mechanism of the coastal farmer. Cropping pattern developed by the farmers are good enough, I think. A question may arise, why shrimps in the mangrove floodplains? it is not wise to ignore the local knowledge and experience of our farmers. Rather, better to say our farmers are scientists, planners, and economists. Our farmers know where, when, which crops are grown well. When water are saline, they produce some shrimps. When water is sweet, they produce paddy or other crops. Farmers also do shrimps where it makes more profit than other crops. Unique cropping patterns of our farmers in the mangrove area or mangrove floodplains. Our coastal land are so kind that never mind to give us fish, vegetables, and paddy from same piece of land throughout the year. That's very dear, just like our beloved daddy. Better the production, better the profit, makes the crop hit. So farmers know which crop, when and where it popular, they will decide their crops. Vannamei in mangroves of Bangladesh, its potential and scopes in Bannladesh. Like other South Asian countries, Bangladesh has enough scope to farm Vannamei. We share almost the same water and floodplains of the Bay of Bengal. Environmental and ecological parameters are almost same. We have a long coastline of 710 kilometers along the Bay of Bengal. We have vast coastal floodplain crisscrossed by numerous rivers and canals. Seawater of different salinities are available in this coastal floodplain. Agricultural crops are not profitable like other parts of the country. Hence, there is enough scope to develop coastal aquaculture. As a coping mechanism of the coastal farmers, shrimps farms are developed in this area. Black tigers farmings are developed in the coastal floodplain. It covers an area about 276,000 hectares. Out of that, 265,000 hectares are black tiger. Vannamei possible in this area, but we don't want to introduce everywhere in coastal belt. A part of it can be used for Vannamei. We don't want to replace BT by Vannamei. In fact, we want to produce Vannamei beside the BT for culture and market sustainability. We can introduce Vannamei in a suitable part of the coastal area where P. monodon and other crops are not growing well based on experience. In some high saline areas where P. monodon are not crop failure occurs often, we can select this area for Vannamei. As a Vannamei has wide range of tolerance to environmental parameter, every talker or presenter described Vannamei has the wide range of tolerance. We have some suitable areas with suitable parameters. We have 3 saline zones, low, mid, and high saline zones. Southeastern part of mainly high saline zone suitable for Vannamei. Southwestern zone also low, mid, and high saline zone also suitable for Vannamei. Temperature of different ranges which are suitable for Vannamei exist in this area. These parameters are more or less suitable for Vannamei. Based on the experience, we can allow the area for Vannamei. Our honorable presenter, Mr. Debashis, already mentioned about the quality seed, importance of quality seed and feed. I would say quality water, seed, and feed in right time, right quantity we need to get the better production indeed. We have a lot of suitable farming area both for monodon and Vannamei. Some farmers are now enjoying with BT, annoyed with BT, want another resilient species. We have a lot of monodon hatchery used or unused. We can redesign some of them for Vannamei PL. Some of the above can be redesigned for Vannamei. Some feed industry can go for Vannamei feed. We have a ready market both in home and abroad. Mr. Debashis mentioned that the Vannamei are in big competition in the world market, but we have some advantages also because we have a lot of monodon buyer. They want some cartoon of P. Vannamei along with the P. monodon. So we have a ready market. Question may arise, why P. Vannamei in Bangladesh mangroves? Why not P. monodon? Why we are thinking about the introduction of P. Vannamei in Bangladesh? Once the world shrimp market was dominated by black tiger P. monodon, Bangladesh was his very tiny partner of the world shrimp market, about 2 to 3% supplier. This contribution comes from the culture monodon, mainly with some freshwater prawn. Bangladesh BT was popular in the world market as it comes from the extensive. Almost organic, being popular in the world market, we did not intensify our culture. Present market situation has been changed. Majority wants cheaper Vannamei. BT is our native species, so we did not want to compete by an alien species. We had business strategy in our mind that almost all of our competitors were going for Vannamei. Then BT have a better access with the market, but actually this not happen. Everybody of our presenter mentioned that Vannamei is cheaper than BT, culture period is shorter, wide range of tolerance to environmental parameters, survival is higher, production cost is lower, on the whole Vannamei is cheaper. As a result, almost all of our competitors switched over to Vannamei. Thus, Vannamei occupy the world market share of 77 to 80% in the shrimp world. Majority consumer prefer cheaper Vannamei. How do we compete? Vannamei is more popular in American market. Once 39% of our production went to USA market, we lose that market due to no Vannamei. Buyers want to buy many species or different varieties from the same market. We did not provide them. Our exporters cannot provide them as because of no Vannamei. Production of BT are not increasing as per expectation. Recently, practice semi-intensive are not so hopeful. A lot of top failure occurs. Production volume are not increasing. In these circumstances, farmers want an alternative resilient species. Our processing plants are always running short of raw materials, only 15 to 18% utilization. So it is difficult for them to survive in the world shrimp market. As a result, production cost is higher, not possible to sell ship like P. Vannamei. So competition in the world market is challenging. Introduction of P. Vannamei can meet up these challenges. That's why we are proposing for P. Vannamei. P. Vannamei in Bangladesh may faces a lot of challenges and hopes. Seed and feed are not available for trial Vannamei farming in Bangladesh. Its expansion depending on success and failure and trial efforts. If the trial farming becomes success, then it will expand. If the trial farming fail, then it will question what will happen. Actually, no. Black tiger production may reduces in almost all the South Asian countries where Vannamei has been introduced. There is a scenario that the production of black tiger reduce. Then, so in case of Bangladesh, if we introduce Vannamei, then BT may reduce. Require infrastructure and investment. Everybody of our presenter mentioned this. If this farming expands successfully, I think infrastructure will develop automatically. Supporting industry need to develop. It will develop if it expands. Everybody mentioned the disease outbreak. Outbreak of new diseases may occur even in epidemic form. So these are the challenges of introduction of Vannamei in Bangladesh, Sundarban. Actually, present situation in Bangladesh, actually Vannamei yet not in practice in Bangladesh. Stakeholders have been demanding from a couple of years ago. They failed to convince the government. It requires government permission to introduce alien species in the country. As a result of continuous demand of the Bangladesh Frozen Food Exporters Association, government has taken decision for trial farming. One farm has been set up in Bangladesh Fisheries Research Institute campus very recently. Infrastructure and pond preparation are going on. Collection of seed, feed, ingredients are in process. Observing the success and failure, government will take next decision. We want Vannamei beside the BT. Existing culture is black tiger, almost come from the extensive and improved extensive. Some semi-intensive are practicing now. Another species, freshwater prawn, extensive, improved extensive. Simply we want to add one more resilient species, Vannamei, beside the bee. Of course, this farm will be biosecure, probiotic, and BMP, semi-intensive. It is form of the culture will be semi-intensive and intensive. Code of conduct, of course, need to follow strictly. Just a simple comparison, why we are thinking for Vannamei. Our beloved neighbor country, India, has a big jump due to Vannamei. At this situation, Bangladesh can think. Up to 2000, India, Bangladesh both produce black tiger almost same. Both produce above 1 lakh tons. In 2001, India introduced Vannamei. And in 2008, government has given the approval. Since 2009, India's productions are booming. Now India is a shrimp giant in the world market. But Bangladesh remains same. And also buyer wants Vannamei to us. Let us think about the Vannamei. We are really in unfavorable condition or with only BT in the shrimp world market. So we can think for Vannamei. We can expect another 22,000 metric ton from shrimp or like Vannamei, from Vannamei. So our existing culture pattern, the area 96% are monodon, only 4% are freshwater. We want to switch over. We want to add one more species, that is Vannamei. Then we can expect another 2 lakh metric ton of Vannamei shrimp. That will save our processing plant, exporters, and farmers also. So thank you for patience hearing. May we respond positively.
Thank you, sir, very much into the insights of the Bangladesh shrimp arena, aquaculture arena. And it's really interesting that how we will introduce and what are the situation there, and keeping the threats, the challenges, still a lot of scope is there, and how can we unravel it for the benefit of the farmers, buyers. So we have a question for you. You answered a little bit a part of it though, but I would like to place it to you that you said that there is the government of Bangladesh has given a call for a trial run. So are there any timeline that has developed that has been framed regarding the trial run and then getting onto the main part with the farmers, the main culture part? So has any framework been developed, or it's how is it placed now with the government of Bangladesh?
Yeah, actually, these are in process. First, a lot of workshops, seminars, and sharing among the stakeholders has been occurred. And the code of conduct for this culture are developing. And first, government want to see what will be the facts in the field. So the question you arise, these are going on. We need to develop a code of conduct for the culture of the Vannamei in which area it may be included and how it can be included. We are practicing. Hello. Yeah. Didi.
Actually,
Didi,
I was
unmute.
lost anyway.
Yeah.
There was some internet issues, I think. Anyway, so thank you very much. And as you were continuously talking about the intention of the buyers, so now we will get on to the buyer scenario. And before that, I must thank you, Dr. Sarkar, for joining us and giving so much of an insight into the context of the Vannamei culture in Bangladesh. And we look forward to more questions may come. So please be on with us. And now, as you said, the buyer scenario. So we look onto the European markets who are really buying, the American markets who are buying. What is the scenario there? So now we are already introduced to Mr. Moritz Konz from the Global Nature Fund, Germany, the young aquaculture specialist who is working, and coupled with him is now Dr. Stefan Holler, who is an expert in the sustainability in aquaculture, working there for quite a long time with a lot of expertise and experiences. So we have both of them with us, and he is with the Naturland, Germany, and we have both of them with us, and they will present on the global scenario of the P. Vannamei culture, its prospect and challenges. So over to you two both, and we are eager to listen to you.
Thank you very much, Ajanta. To make it easier, I will give the talk, but I got a lot of input from Stefan Holler, so we can see it as a cooperation then. So give me a second. I share my screen. So please confirm when you can see the presentation. Is it visible?
Yes.
Thank you very much.
Yes, it's
perfect. As Ajanta introduced so kindly, I will talk about the global scenario of Penaeus Vannamei culture and its prospect and its challenges. So yes, what was mentioned in the previous presentation is in fact true. Penaeus Vannamei took over the shrimp market, and Penaeus monodon isn't isn't the favorite species right now at the global shrimp market. I will talk a little bit about the global production numbers and the export markets. I specifically focused on the EU as export market because just to keep a loop to our project, which is related to, of course, the trade in Europe. And as well, regarding to the global production and the global aspect, I will also again talk about the topic of invasiveness, just to keep it under one topic, because the worldwide spread of the species, of course, contributes to problems that we heard 4 million times now. But I will just go on with these topics in detail. The global production numbers are shifting towards Penaeus vannamei, and up to this point, it's the most cultured shrimp in the world. And as we heard before, there are easy production methods and suitable, and it's very much suitable for intensive production, which also explains higher numbers and higher production numbers. Here, I showed this map before. We can see all the global countries that are producing Penaeus, Penaeus vannamei. So originally, as we know, the shrimp is coming from the coast of Mexico down to Peru. But right now, the main producers are actually in Asia, with leading numbers. I was searching out all the data, production data at the FAO statistics tool, where you can find the most recent production data. And first of all, I would like to give an overview about the worldwide production according to the country, to the continent. And the top producing continent is Asia, as I mentioned before. Asia is producing alone in year 2018 over 4 million tons of Penaeus vannamei. If we see, it is closely followed, not really closely followed, but it's followed by America with over 800,000 tons in 2018. What is interesting, I also included Penaeus monodon into the statistics, and in whole Asia there is over 700, almost 750,000 tons of Penaeus monodon produced. So keeping in mind that Penaeus vannamei is not a native species in Asia, the production numbers are quite impressive. If we focus on Asia, again, as I told before, I ruined my own presentation there. So we have over 4 million tons of white leg shrimp and approximately 750,000 tons of black tiger shrimps in 2018. We can divide this information even closer to the whole production in Asia. And here we can see the main production of Penaeus vannamei in Asia, and the main producer is China with 1,760,000 tons alone in the year of 2018. And this is followed by Indonesia and closely followed by India. India is producing 600,000 tons per year in 2018. And of course, as we heard in the discussion before, in Bangladesh, the production is currently not allowed. So there is only black tiger production, or mainly, let's say, black tiger production. For the year 2018, Bangladesh was producing 60,000 tons, and India almost 60,000 tons too of Penaeus monodon. But here the leading producing countries are Vietnam and Indonesia. Vietnam with 290,000 tons of Penaeus monodon just in 2018. What we can see is that the production in many countries such as India is stagnating, isn't growing in regards of Penaeus monodon, but Penaeus Vannamei instead is increasing, which has to do a lot with the market demand. And speaking of market demand, I would like to focus on the EU because it was easier for me to generate the data using the Eurostat statistic tool from the EU. What I can say from the beginning, it's difficult to distinguish how much Vannamei and how much monodon have been imported. This is just because of the statistical tool doesn't divide in species, they divide in product groups. And there can be an overlap in species with the tools I used. But approximately what we can say for the European Union, especially for countries, for the Netherlands, the UK, Germany, there is 90% of the approximate market share is Penaeus Vannamei at the moment, and 10% is monodon. Yeah, the EU imported approximately 400,000 tons of shrimps in 2015. And from this number, 44% came out of Asia. And the main countries we are sourcing are Bangladesh, India, and Vietnam and Thailand. Interesting is that the main consumer markets, which are the Netherlands, the UK, and Germany, are mainly importing the prawns from Asia. In comparison, for example, Spain or Portugal, they mainly import from South America their shrimps, which might have to do with the language, of course. But yeah, so for our shrimp import, Asia is one of the top important markets, and also Bangladesh and India play a huge role with that. So just to say about the export, for example, in India. So in India in 2017, the Netherlands imported 12,000 tons alone from India from Penaeus Vannamei, and the same similar Belgium and the United Kingdom imported 14,000 tons from India in 2017, and France and Italy as well together imported over 10,000 tons as well. So a very interesting thing that we have to consider, which was mentioned before as well, is that our imports are growing quite heavily because we all love shrimps, and shrimps are getting cheaper and cheaper on the market. And due to the high imports, the price levels are dropping. So approximate numbers are that from 2013 to 2017, the shrimp price for Vannamei in US dollar dropped from $11,600 US to $8,600 US, which is a very, very drastic reduction, which is relating, of course, with more production of Penaeus Vannamei and also more countries who are producing. And due to the high production, of course, the price pressure is high. So this is just a critical point that we need to think of. For example, when we think of the last presentation, where we definitely could see that Bangladesh is struggling to provide enough black tiger shrimp to keep their factories running and to compete in international prices. And here we can see that the price level is very much competitive. And we can also see we can also think about if Bangladesh is also joining the production, that also might shift the general prices as well. So it's a very interesting and vibrant topic that will develop quite a lot in the future. Related with the topics of the global trade and global production is always the invasiveness. So this is something that is mentioned quite frequently. And I've shown this map before, but here I also marked the origin of Penaeus vannamei. And we need to figure out whether invasiveness is an issue for Penaeus vannamei. If we try to define invasiveness, there are many different words that are used. There is once the introduced species, a non-native species, alien species. We also say invasive or exotic species. So just to figure out the definition and usage of right terms, I would like to give a shorter intel in the definition and see whether Penaeus vannamei is invasive per definition. So in biology, we tend to say that invasiveness or that this is suitable for plants or animals that are introduced to an area, survive, and reproduce and expand beyond the original area of introduction. So we have four words that are marked here because I think they're really important to figure out the status whether a species is invasive or not. So one is introducing, then surviving, reproducing, and expanding. So, and another important and interesting aspect from my side is that there are also legal terms, not only from biology. So there are also legal terms here, for example, from the US executive, how to define an invasive species. They say an invasive species is an alien species whose introduction does or is likely to cause economic or environmental harm or harm to humans is also added there. So that's also a very important and interesting thing we need to think about when we want to distinguish whether Penaeus vannamei is invasive. So that's the question, is it invasive? We searched for some publications and we are coming to the clue that for the first word, introducing, that happened with Penaeus vannamei. It's introduced by aquaculture activities, and sometimes due to poor farm management or due tropical storms, Penaeus vannamei is able to escape and is introduced into the wild. So there have been also some catches of Penaeus vannamei in the wild next to aquaculture farms. So these numbers can be significant depending, of course, of the area and of the farm management. So they show, if they escape, they show a high survival. So we can check the second word as well. So another point that is critical is reproduction. But right now, from the scientific point of view, there is no established breeding population that has been discovered yet outside of their original distribution. So right now, the proof for reproduction is missing. So from the current data set, we can say there is no reproduction going on right now. At least there is no proof for it. So, and when we think about this, this legal definition, does it have an impact on environment, on humans, or on economically impact? We can say from this point that the farming has been affected due to the introduction of these shrimp species, because shrimp diseases spread more globally. This could be observed in some viruses especially, but what we don't know right now, and where is a lack of studies, is whether there is an impact on the wild stocks as well. There have been no significant result in that regard right now. So, and a very good hint from Stefan Holler, from Dr. Stefan Holler, was to also consider GISD, the Global Invasive Species Database. This is a free database where you can see alien species and see whether they have a negative impact on biodiversity. This database is well known, and but to the present point, there is no entrance for Penaeus vannamei in this database as invasive. I think, or I'm most likely sure that this is because of the lacking reproduction evidence and the lacking evidence of influence to wild populations. And this database is very interesting and is managed by a specialist group, and is very much a good source to decide about these kind of topics. So to wrap up right now, by terms of definition, we wouldn't say Penaeus vannamei is an invasive species, but we are still missing a lot of evidence. So, and yeah, again, I would come back to the spreading, to the challenges, why we shouldn't say, if it's not an invasive species, there are no issues then. There might be issues that we need to address and that we need to think about, because especially the carrying of viral infection and the spreading of these viruses can be an issue. Or have been an issue in the past. As we know now, there are many new strains, but the question is whether these strains can carry or not. Most of them do not, but there's still more work to have to be done in that regard, and we don't know any consequences to the wild stocks yet. Suspected viruses that have been brought to Asia is, for example, the Torres syndrome virus, which is originally located in South America, but there are many more. We heard already about them. So as a final sentence, even though there is no clear indication that Lithopenaeus vannamei is established, has an established population outside of its original distribution, we also need to consider the introduction of diseases or parasite or anything similar. So thank you very much for your attention, and if there are any questions, feel free to ask, please.
Thank you so much for the insights, Moritz, into the invasiveness, the definition of it, because in India, we know that the National Biodiversity Authority has declared P. vannamei as an invasive species. And that raises a lot of eyebrows for us. So in spite of having so much of economic and social impacts on the small scale farmers, where they are really adapting such things, we are always concerned as to, wow, that's an invasive species. So I will put the relevant points that you raised to also our NBA Chairman, Government of India, and also Government of West Bengal, to go deeper into the to the understanding of declaring the species as invasive. And incidentally, I do not have any questions to you in this respect, but I have certain questions from the previous discussions, which I would like to take this opportunity to place. And thank you, Moritz, once again, and Dr. Stefan Holler for all your inputs. And I think whoever are participating will definitely look into those websites and try to understand the situation deeper and deeper to get into the complex dynamics, because we all understand that there is always this dilemma of economics and ecology. So it has to be resolved. It is a journey. I feel that with the process, humanity is addressing these issues, trying to solve it, and also addressing the other issues that are related, especially the sustainability issues, which is the most important thing in terms of everything, that what includes everything of it, not only ecology, but the social economics and everything of it. So I have certain questions. So thank you again to both of you. And now my question is to Dr. Debashis Dey. We have certain questions too, as I said earlier, that one thing that you already pointed in your discussion was that inbreeding, and that some disease outbreaks recently that has been noticed. We also are seeing that the farmers are shifting from Vannamei to other alternatives. So there is a question that whether there is a opportunity or possibility of interbreeding also. So is there a possibility of interbreeding also? This is one question. And another question was that, as you said, that there is a PL Vannamei availability is an issue, and the seed is a very important factor, as you said. So how is it becoming available for the small scale farmers and the production to continue? So what is the Government of India and SIBA as the nodal institution thinking on those terms to make the seeds available on a sustainable point of view to the small scale farmers? And as I remember, during this particular pandemic, since the brood fish was difficult in importing from other countries, from the Latin America, I was part of a discussion in the fisheries department when they were saying that due to lack of this import of this brood fish and the availability of the Vannamei seeds, the Vannamei production in West Bengal has suffered a lot during the pandemic. So related to all this, if you can reflect on these, that how are the PL Vannamei availability to the small scale farmers, and also that interbreeding possibilities if there exist. Thank you, sir.
Thanks, madam, for just raising these issues. I'll just come one by one. So first one is whether interbreeding is possible. Because now some of the hatcheries, they are without importing also, they started doing pond rearing, and with that pond reared broodstock, they started hatching and they're producing the larvae. And that's why I was telling that maybe due to the inbreeding, that the slow growth is coming. That's the one issue why they now present so many farmers are complaining about the slow growth of the, even in our farm also we are seeing, though it is a free from EHP. Most earlier we used to think maybe it is it is carrying EHP, but though it is EHP free, but there is a slow growth. This may be the different issues also regarding the environmental thing, because if your salinity is less and you are not providing much minerals in the system, then your growth may be slowed down. But another factor also may be there, that's due to the inbreeding in the hatcheries, pond reared broodstock. Yes, of course, that interbreeding, as SIBA started doing that crossbreeding thing. So it is in the research. It is yes, it is possible. In the first instance, we have seen that yes, it can do. But it is in the research stage, so I won't comment much on that interbreeding. But it is possible. It can breed. It can breed. It can crossbreed. Okay. So that is the one issue. And next is the your point is the how for the marginal farmer seed can be made available in this zone. Madam, actually there were a lot of discussion even just 1 month back also. West Bengal government, West Bengal secretary just had a meeting with me regarding that giving the some evaluation So whether this hatchery is possible in West Bengal or not. So then I had given some of the requirements. I told these are the things you have to provide me. Then we can evaluate. So beyond that also, I will inform this house that now in Digha, one hatchery has come. This is your Raj Hatcheries, Raj Bengal Hatcheries Limited. Yes, Raj Group. They are having the hatcheries in Chennai, but they just also established a hatchery in Tajpur near Digha. So this now at this point of time, they're now doing the noply rearing. But they are not doing the here breeding thing. At this moment, they are just bringing the spawn and then rearing here, and then selling in the or in West Bengal market. So it is catering in the end. But we have to again be very sure that regarding the quality of the seed. Definitely because some point of time this farmers are telling that maybe this hatchery what they are giving may not be of good quality. This my seeds are not going. But that may not be also the hatchability issue, maybe the environmental thing. So a lot of it is a complex things, and because why your animals are not growing. It may be the seed quality, it may be your feed quality, it may be your environment. So that all the things, if it is a good and it is not growing, then we have to think really there is a problem in your seed. But anyway, we are government of India also thinking, government of West Bengal is also thinking to establish a hatchery in Bengal. And we are also ready to help to give our consultancy for establishing this hatchery. And major problem in establishing here hatchery is the two issues. First is the turbidity and second is the salinity. Here turbidity is the too high. So any hatchery need to establish the settling reservoir. If they should have the settling reservoir, what Raj hatchery is established already. Settling reservoir to just get rid of from your the turbidity issues. And this salinity, they are telling no salinity. This what I had a discussion with Chairman Raj Hatchery Group. They told that salinity we can make because we are making the well there in the sea itself, and we are then pumping out the water. So salinity can be just managed. So we are hoping that in near future we can have seed in our West Bengal. Okay, thanks, madam.
Okay, that's a very, very good news in terms of Vannamei culture, and hope for the small scale farmers if that brings.
And one more thing, just to add upon, because this SIBA is having the MOU with the Raj hatcheries regarding the milkfish hatcheries. Because we are mainly having the MOU with them regarding the milkfish hatcheries. It is just going on. We are developing our brood stock here in our farm, and we will be supplying the brood stock to them. So they are doing the this hatchery for the milkfish. So that is information, add-on information.
That is a very, very good information for our IMA farms, because we believe in the polyculture, and milkfish is a very, very essential component of the system. So thank you, sir, very, very much. We are more geared to do IMA now. And we have, because this milkfish supply, we always faced a challenge with this, but thank you. And one more question, I think I can address this to Moritz and Dr. Stefan Holler, that there is a question that as you need from Vannamei, it is regularly said that we understood that it's a chemically intensive farming. And then what do you think of organic certification processes? That does it, will it hold for organic certification processes? Because now that we are the world is going more and more organic type natural processes. So what are the challenges? What are the scope? There is one question on that. So if you can address it.
Moritz, if you don't mind, I will address that question. Is that fine for you?
Sure, I would have handed the microphone over to you anyway, so perfect.
Okay, great. Yeah, thank you very much to the audience for listening, for your attention, for your interest, and thank you for that interesting question. Well, generally, we have to consider which regulation is applicable. So we have here in India, we have the NPOP, the National Program for Organic Production. But okay, now let's consider the European Organic Regulation, because all products you want to export to Europe have to be certified or have to comply with that EU Organic Regulation. And the EU Organic Regulation basically does not exclude the Vannamei shrimp. So in fact, there are several projects in Latin America where Vannamei shrimp are certified organic. So that is possible. Also in Indonesia, we have a project which produces Vannamei. So they are certified organic Vannamei. Of course, they have to comply with certain criteria from that organic regulation. For example, stocking density. The maximum stocking density for shrimp, according to the regulation, is 22 post-larvae per square meter. So you cannot go higher. If you want to have an organic Vannamei, that's the maximum you can go. Regarding the feed, the regulation requires organic feed ingredients. So you will need to establish either a feed producer who can provide organic feed, or import organic feed. That's an option. Also, the PL have to be from certified organic hatcheries. So those are certain requirements. Also, of course, regarding the use of chemicals, all these kinds of things, which make it complex certification, organic certification, but don't exclude it completely. And then, of course, we have the other question regarding the alien or invasiveness of a species, because the organic regulation clearly says that local species shall be preferred or shall be used. Now, regulation defines local species as neither alien nor invasive or locally absent. So that means, okay, what is the question? When would you consider a species as is not alien? So for instance, in Indonesia, the Vannamei shrimp has been introduced many years ago. So in that case, we could consider it as not alien anymore, because it has been produced, and the regulation also gives an option to species which are originally alien, but they have been introduced to a region for a long time already, then they can be certified. I give you an example for Europe. So in Europe, for instance, the rainbow trout or the Pacific oyster are not native, but they have been introduced long time ago, and the EU regulation explicitly allows these species to be certified organic, even though they are not originally not native. The same in Indonesia. It's up to the inspection body to decide if that species would be considered alien or not. So if it has been produced for a long time already in that country, it may be considered as not alien anymore. For Bangladesh, of course, it's very difficult, because Vannamei is not produced there yet. So if, let's say, next year or in 1 or 2 years, a Vannamei producer would approach an inspection body and ask for organic certification, it would be very critical, or I would say impossible, because that species for Bangladesh would still be considered as alien. So I think organic certification of Vannamei in Bangladesh is for the next years probably critical. For monodon, yes, we have a certified project for monodon, organic certified project for monodon in Indonesia, in Bangladesh and in India. So that's of course possible. But for Vannamei in India, it would probably also be possible, because Vannamei has been introduced for such a long time already. In Bangladesh, organic certification of Vannamei is probably critical. At the moment, I would not see any option for that. But we have other certification schemes like ASC, so-called Aquaculture Stewardship Council, which plays a very important role in the European market also. If we talk about sustainability, so we can look at these other sustainability certifications, and ASC also has some certain criteria regarding alien and native species, but yeah, that's another option we can have a look at.
Okay, thank you, Stefan. That gives a lot of hope for the farmers who are intent on Vannamei to go for organic certification, because that makes the production process more concrete, considering all the ecological and the social and economic sustainabilities together. And we are all hopeful about that. And thank you so much. And I have the last question to Dr. Prafulla Sarkar, that you have considered, you have told, sir, about the introduction of Vannamei in Bangladesh. Well, there is a question for you that with this, don't you think that the other aquatic biodiversity species, uh, what will be the impact on the other aquatic biodiversity species? I think the question intended is that so much of chemical, so beyond monodon, what can be the impact? Is there any assessment, or how do you look at it?
Thank you for question. I think last, not least. In fact, we have some experience on coastal belt, both improved extensive and semi-intensive also. In case of P. Vannamei, we would like to introduce only in the particular area with proper infrastructure, with proper device of ETP and other management. So I think it will not affect. We are not interested to hand over it to the extensive like our monodon. So in case of the controlled farming, I think proper protocol will be followed, and biosecurity and other management arrangement will be set up. So I think it has a little impact on the environment. If we follow the proper guidelines developed by our government and as well as our community, production community. So I think it will be not so harmful for the, because all of us are now much aware about the environmental disaster. So if the pond is structured, if we keep the provision of the ETP, if we select the area properly, then it will not so harmful. Of course, there's the improved culture or the intensive culture. There have a chance of polluting the environment. But everybody now are almost aware about that. So we'll need to develop a code of practice for this culture, and in that case it will do not much hamper to the coastal area.
Thank you, sir, very much. And I thank all the panelists. Before I give my floor to the microphone to Mr. Milan Sinha, he's working on the fishery side for quite a long time, and he's working with the Nature, Environment and Wildlife Society. So, Mr. Milan, if you can now summarize, it's very difficult, I can understand. So many points have been raised, but try a bit and try to summarize and thank and give the vote of thanks. And over to you, Mr. Milan.
Yes, thank you, Ajanta Dey. Actually, it's really, as mentioned by Ajanta Dey, it's a really very difficult task to summarize presentation from the esteemed experts on various aspects related to P. Vannamei culture in India and Bangladesh. I will try my level best, and I will also request Ajanta Dey if I miss anything to supplement. In the we have come across 5 presentations today, and with the introductory speech from Ajanta Dey. And in the introductory speech, Ajanta Dey has explained that in the background of the SAIME project and how the P. Vannamei is important in the context of the SAIME project, whether it can be integrated in the IMA culture as a choice species. as an alternate of P. monodon or with the P. monodon. So maybe another species for this shrimp in maybe exotic or invasive, anything is called. But whether we can choose it, this is the background, and in that context, this workshop, earlier we organized internal workshop in our team, and then we decided to make it, by a wider platform to get real insight into it. And for that, it has been organized, and Ajanta Dey has explained it. Then in the very first presentation in the keynote address, Professor Sarder, he has explained in detail the biology of the species. And from there, what are the advantages? If we can summarize in 2 lines, what are the benefits or advantages we have in Vannamei culture from the economic point of view, and what are the challenges basically from the ecological point of view or from the environmental point of view. And from that point of view, the Professor Sarder has elaborately described the advantages of the Vannamei culture in respect of the biology of the species. These advantages are the wide range of salinity tolerance of the species. That is a big challenge for monodon culture. If the salinity fluctuation is wider, the monodon culture is affected. And the second advantage is the culturable in the species. Vannamei is culturable at higher stocking density than P. monodon. And the faster growth rate, at least in the initial stage, up to 20 grams, it goes faster than P. monodon. And the low temperature tolerance is also a factor which is considered as an advantage for Vannamei culture. Lower protein requirement in the feed. That's a big thing because most of the input cost goes into the feed cost, and as it requires lower protein in feed and FCR is low, so the culture cost is reduced in case of Vannamei. This is also a very good advantage. And better larval survival in the initial stage. It is also an advantage for the Vannamei. And easy availability of hatchery weight seed. Though there are some constraint of availability in abundance, but in India, SPR and SPF seeds are available because there are some hatcheries in this southern part of the India, as Bangladesh is yet to allow this. There is no hatchery, but in India it is available, and in Southeast Asia countries it is very much available, the SPF and SPF seeds. So this is an advantage, as farmers are not to depend to wild stocks, and wild stocks are not degraded due to farming, which happens in case of P. monodon. So this is an advantage, and most of all, there is a huge export market potential for the species. And so these are the advantages. On the other hand, there are some ecological challenges. The challenges is that the species is said to believed to bring some disease in the native with it, and which is very much affects the native species, especially Penaeus monodon and other species. So especially Tora virus syndrome and LOV virus syndrome, and so these have a very much negative effect on the culture of the introduction of the culture of the species, because the native species can be affected by these. And another disadvantage is that it is very much input-based culture system, where tons of nutrients or other chemicals have to pour into the system, which may cause some environmental impact. These are the points which was addressed by the Professor Sarder, and she also mentioned that during in case of propagation of the culture in Bangladesh context, the lack of knowledge for the farmers is a big issue.
Milonda, you're mute.
You have to unmute yourself.
And then we have a presentation from Mr. Moritz Konz, a comparative analysis of culture between P. monodon and Vannamei. There, Mr. Konz has described the origin of the species, and he described the geographical distribution of both the species, Penaeus monodon and Penaeus Vannamei. And he also showed that in case of Penaeus monodon, there are three systems of culture system, which is a polyculture and intensive, semi-intensive, and polyculture, which is also a extensive culture. But in case of Penaeus Vannamei, the culture is either semi-intensive mode or intensive mode. So culture with higher stocking density is possible, and the production, he has given a comparative discussion of the production, where in case of P monodon, in case of semi-intensive farming, the stocking density is 15 PL per meter square. In case of P Vannamei, it is up to 69 PL per meter square can be done. So it can be done in the higher stocking, which has also been mentioned by the Professor Sarder's presentation. And where in case of P monodon, in semi-intensive farming, the production is 1 to 5 ton per hectare per year. In case of P Vannamei, that can be 10 ton per hectare per year, almost double. And in case of intensive farming, that 90 to 180 PL per meter square can be stocked, which can give an yield of 15 ton per hectare per year, almost 3 times. So these are the advantages for the P Vannamei culture. P Vannamei culture other than P monodon or other species. And the culture period for P monodon is 90 to 120 days. In case of P Vannamei, it is 90 to 100 days. So shorter culture period is an advantage for which the farmer can go for the diversification of the species. And though he very much mentioned that the Penaeus monodon is still believed to be the ideal species for the integrated mangrove aquaculture, because it's a native species. It has environmental suitability and ecological suitability. It's also mentioned in his section. He also mentioned some risks in propagation of P Vannamei culture. The risks are mangrove ecosystem destruction, because this has been witnessed during the propagation of P monodon culture also. Rapid destruction of mangrove ecosystem took place in the 80s, 90s in Southeast Asia, when the P monodon culture took a space. That can happen also in case of P Vannamei, and more mangrove destruction, ecosystem destruction can happen. And intensive use of inputs, that means feeds, antibiotics, and that can ultimately lead to eutrophication of the coastal aquaculture system, which is a great danger, because the normal phytoplankton, zooplankton production in the system will be hampered by that. So when we are pouring tons of feeds, tons of antibiotics into the system for culture, that we ultimately release to that nearby coastal water bodies, and that can lead to eutrophication. And escape to natural system, he has also described this as a threat. You know that has been pointed out by several speakers, which is been believed to be a threat for the P monodon or introduction of P Vannamei, because it can be released to the natural water bodies, and if breeding happen there, then it can bring so many problems, especially the change in the genetic pool, and genetic toxication may happen, and the breeding may cause the displacement of the native species, that is black tiger shrimp or Penaeus monodon. He mentioned it, and he also mentioned, which has also been mentioned by the many speakers, that it can bring exotic diseases, which has also been described by Professor Sarder and later on the other speakers. And he also advocated to introduce or consider Macrobacterium rosenbergi for Macrobacterium rosenbergi as an alternate species for alternate species. This was his presentation almost. And then Dr. Debashis Dey gave his presentation, Scope and Challenges of Pea Vannamei Culture in Indian Sundarban. He mentioned that India is the second largest country producing second largest fish producing country in the world. And he also mentioned that he gave detailed statistics of the production. I am not going into the detail. Almost he told that in West Bengal, 4127 hectare has been brought under the pea Vannamei culture, and 90% of the shrimp production in India now from pea Vannamei, and gradually the Penaeus monodon culture is getting reduced, and pea Vannamei culture is increasing. That he gave his presentation. And he also, though he also pointed out that 80% of Indian Sundarban area is being utilized for the scientific aquaculture, shrimp farming so far. So that needs to be extended. And he also described the historical background of introducing pea Vannamei in India, because the institute where he is attached as a principal scientist that took an instrumental role of introduction of the species for assessment on with National Fish Genetic Research Bureau. He also described all these things, and he also then he gave the details of the culture system and culture methodologies to be adopted for pea Vannamei culture, scientific pea Vannamei culture, and all details in detail he described the methodology for feeding, for disease control, for pond management, for stocking, maintenance of stocking, etc. I'm not going into the detail, but one thing especially I like to mention, especially because we have a common idea that the shrimp are nocturnal in feed habit, but he mentioned that unlike Penaeus monodon, Penaeus Vannamei is not fully nocturnal in feed habit. That is a special mention in his presentation. And as challenges, he put the points of that is input intensive, that is carrier of various diseases, high density culture leads to environmental problems, which all already addressed by the other speakers also, and high susceptible to hypoxic condition. Market competition is higher, and he also specially mentioned as ecological risk, the escape of to the nature and affect the biodiversity, destruction of mangrove, conversion of agricultural land to brackish water aquaculture. And though he mentioned that the guidelines should be guidelines are there, and that should be adapted as a mitigating strategy to between the environmental friendly culture and how to develop environmental friendly culture. There are for that there are guidelines that should be adopted, and in by that the scientific Vannamei farming is possible. And he also mentioned the slow growth rate of the P. Vannamei, which has also been asked by Ajanta Dey in his questions. Actually, he mentioned that due to inbreeding, as the farmers are raising brooder in their ponds, and these pond-raised brooders are being used for production of the seeds instead of SPF and SPR brooders, which are brought from the Latin America. So it is costly. So farmers or some hatchery owners, they do breeding with these locally pond-raised brooders, and these seeds are not quite good. Specifically, there is a genetic drift, genetic regression due to inbreeding, and that is causing the slow growth rate of Vannamei, and which is the farmers are complaining about these nowadays, and they are losing interest for that. This is the point.
If I can interrupt you, you have to be a little faster.
Okay.
We are running out of time.
Okay. And
Thank you.
In his presentation, Mr. Prafulla Kumar Sharkar, he described the need of the propagation of the Vannamei in Bangladesh context. Especially, he mentioned that the changing pattern of SAIME production in the Bangladesh. And though he said that though there is a black tiger SAIME is a native species and that has a market, we believe, but in the international market, it is witnessed that the Vannamei is more preferred, and buyer for the Vannamei are there. So there is, though black tiger SAIME is consumer preferred, but it is losing the international market. So there is a situational compulsion for going to diversification of the species in Bangladesh context. And in Bangladesh, there are fluctuation in salinity range, and farmers know very well how to cope up with this situation. And he especially mentioned the high saline zone of the Bangladesh, which is not conducive for black tiger SAIME culture, can be used for these P. Vannamei culture. And in the last presentation, in the global scenario of P. Vannamei culture, Mr. Moritz Konz and Dr. Stefan Holler, they showed the scenario with the statistical figures. And they gave an overview of that, and it is they showed that the 4 million tons of farm seed has been exported from the Asian countries in 2018, whereas the second producer is America, which is almost 0.9 million tons. So, and in India, 6,000 tons of Vannamei was produced in 2018. So Vannamei production globally, it is increasing. It is the most cultured species, cultured SAIME species in the world. And with accordingly, this has also been propagated in the Southeast region, Southeast Asian countries, and in India also, and the production is gradually increasing. And because there is high export potential of P. Vannamei, out of 40% of this production, export amount has been coming from Southeast Asia countries. Then he dealt with the invasiveness points. He described its scientific definitions with invasive race, whether it is alien or invasive or exotic. But he concluded that though there is chance of breeding in the natural water bodies, it is bringing the disease. But in IUCN and other global platforms which rates the invasiveness of a species, especially the global invasive species database, DSID, and IUCN, they are still to announce the species as invasive P. Vannamei. So We know that Ajanta Dey has mentioned Indian Biodiversity, National Biodiversity Authority has announced these as exotic species. So with that, he concluded that the invasiveness is there, but we have to conclude whether the species is invasive is not through scientific trials. Because the breeding is yet to be proven in natural water bodies. So with that, we can conclude that again there is huge potential, economic potential for culturing these species, as it gives economic return to the farmers, and the water bodies here are very much conducive for culturing these species. But there are certain ecological risks, which the change in gene pool may occur, modification in natural benthic community can happen, modification in nutrient design can happen, there is a chance of threat and loss of native species, such as a biodiversity threat. There can be the disease transmission and eutrophication of the coastal water, conversion of agricultural land into the aquaculture land, and mangrove ecosystem destruction. So with that, these are the risks and challenges. And on the other hand, there are benefits, huge economic benefits there for the species, as the species has a huge export market, even the domestic market, and highly consumer preferred. With that, I would like to thank all the panelists, Mr. Moritz Konz, Dr. Stefan Holler, Dr. Debashis, Mr. Kumar Sharka, Professor Sarder Islam, for giving their time and for this workshop and delivering such a beautiful lectures which has enriched the today's discussion. I also thank Ms. Ajanta Dey for encouraging and guiding conducting such a good workshop. I thank my colleagues in the SAIME team news for their effort to organize this webinar. I also thank Mrs. Wendila Chakraborty, the HR admin of news, for organizing this whole workshop in Zoom platform. With that, I also thank to the participants, esteemed participants, who for their listening, for their patient listening and participating in this. That I thank you all. And if I miss anything, I will request Ajanta Dey to supplement.
So the concluding remarks from me. Thank you, Milan, for the summary. It was really difficult, but you tried the best. And I really congratulate you on that point. And with this, we are concluding this session. But before that, let me acknowledge my partners, the BMZ from the German Corporation, and our partner, Global Nature Fund, and Naturland, and most importantly, Bangladesh Environment and Development Society, BEDS, Maqsudur Rahman, the CEO of the organization, and the team, a vibrant team working there, and a vibrant team working here in India also. With all the experts, we would like to go forward with our sustainability and ensuring the sustainability of aquaculture in mangrove ecosystems. And surely we think we will do it with all the inputs and thoughts that are there with us today for coming days, to ponder, to search, to do more research, to go for more literature surveys and build something very, very concrete with the last marginal farmers, to take them into the shrimp trade, have the ecological standards, the economic benefits, the social benefits be distributed within the human society as a whole, and look forward to a transformation in the shrimp trade in the tropical mangrove ecosystems. So thank you once again, and we look forward to walk together in the future. Thank you once again. Bye-bye. Have a very good day. Have a very good evening.
Thank you very much. Goodbye.
Thank you.
Thank you,
Goodbye.
Bye.
Goodbye.
Thank you.
Yes.